10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's go.
Okay, good afternoon, everybody. Welcome to the Copernicus for the Green Deal workshop. So I'm glad to see you all and that you are here, and I hope that you will have useful time during the 2 half days of the workshop. So my name is Ivan Konakchev, and I will guide you during this first day of the workshop. As you know, the workshop is organized by DG DEFIS from the European Commission together with the help of our partners, which are mainly the Copernicus and trusted entities, and in particular EAA, the European Environment Agency, and ECMWF, together with the DG GRC and USPA, and also other participants, in particular our contractor NCI, who is dealing with the logistics. So I would like to thank all of them to support this workshop, and I would like to thank you also, all of you that attended the workshop. I hope that this will be useful for you, and you will come with a lot of ideas, and you will leave with even more ideas. So the purpose of this workshop is to present how Copernicus services can contribute to the achievement of the EU Green Deal policy objectives and support mainly the monitoring of its progress. So the workshop aims to address the policy areas indicated in the Green Deal, how Copernicus can support implementing and monitoring these key aspects, and facilitate interactions and discussions between different stakeholders. I will not take more time now, but I will invite Mauro Fakini from the European Commission, who is the head of the Earth Observation Unit and leading the Copernicus program. So Mauro, can you hear us?
Yes, thank you very much, Ivan. I hope that you can hear me and you can see me. Can you confirm? Yes, I see that you are
Yes.
nodding. So thank you very much. So it's a pleasure, first of all, for me to open this workshop. Indeed, we are speaking about Copernicus, but it's really the link with the Green Deal. We are really linking today what we are doing. So what has occupied us for so many years with one of the biggest priorities of the European Union at this moment, so the Green Deal. So in this respect, thank you very much to all of you for joining us. So indeed, the panelists, the speakers, but also all the public. It's indeed it's a pity that we cannot have this event physically, in order also to have some direct contacts. But at least I think we have been used now to have virtual format, and I think that is, as I said before to some colleagues, it's better to have that at least in this way than nothing. So the European Union, through Copernicus, is the largest Earth observation data provider in the world. And we know that it makes available several petabytes of global data from satellites, integrated with ground-based, airborne, and seaborne measurement systems, and with modeling capacities. It responds to EU policy initiatives in different areas, ranging from environment, climate change, security, emergency. But clearly, as I said in the beginning, Green Deal is an overarching topic that is covered also by or supported by Copernicus capacities. Copernicus is a component of the EU Space Program. It has 6 services. I will not go too much in this detail because you will hear from different presentations today, and provides long-term data records that are covering several decades, and so they're useful also for understanding our planet and also to see how our planet is changing. Concerning the data it generates, in particular when we speak about environmental data, it provides free and openly accessible data, actionable information to help service providers, public authorities, and other users to prepare Europe and its citizens for the critical challenges brought by climate change. I would like also to underline the research users. We don't speak very often about research users, but indeed they are also among the big users of the data generated by Copernicus, and through their research they can really provide additional information in support of Green Deal transition of our planet. If we look back to the last 7 years, we can say, and we are not saying that, I mean, many people are saying that the quality of Copernicus has been quite impressive. So Copernicus has grown up, it has reached a cruise speed today, it's operational and very much appreciated every way. It remains a leader in Earth observation and monitoring at world level, and it's really the idea and the ambition is even to move forward. With the new space regulation, we are entering in the second phase of Copernicus 2.0, to cover the next, let's say, MFF period, 2021 to 2027. And this will look, we'll see evolution on the space components. So the Sentinel satellites are evolving, and we'll hear from ESA as well, the plans for that. And we have also very long-term plans where we look into new observation capacities, combination with new space, and so on. But in parallel, it's not just the space component that is evolving, but also the services generating more and more information, more and more adapted to user requirements that could also impact environmental policies, both at European level, but also at member states level for the green transition. Maybe I would drive one element. So a crucial capability of this plan is about CO2 monitoring mission that will be, in our view, a game changer in the monitoring of greenhouse gas emissions. And so we hope that this capacity will help also to deliver on the climate action activities foreseen by the European Commission, in particular, to reach the target to be to have a reduction by 55% of CO2 of greenhouse gases by 2030 with respect to 1990, and to arrive to a level of 0 in 2050. In the current workshop, we'll hear from expert speakers how the information made available by Copernicus enable us to make informed decisions on how to best fulfill Europe's ambitious targets, while also preserving, as we spoke about climate, about greenhouse gases, but also important, preserving biodiversity and ensuring clean energy and transport. So the Copernicus program will support several DGs of the Commission, several EU policies, providing essential elements towards the implementation of the EU Green Deal. We will see during these 2 days also prominent examples that will be shown by different participants and speakers. So just for concluding, I have to say that we have an operational system, but we have also great challenges in front of us, but also great opportunities in the next 7 years. And so we hope really that this program, which we have been working for so long, will even bring additional and useful information and support to this evolution. So in the meantime, we are looking forward to this 2 days, actually 2 afternoons of interesting presentations, panel discussions, and question and answer and interactions with online participants. I will not take too much of your time, and I wish all of you a successful workshop. And I will, maybe as a last point, thank all those colleagues that helped to organize this event, and all the speakers that really accepted to share with us this challenging event. Thank you very much. Over to you, Ivan.
Thank you, Mauro. In fact, thank you very much for introducing the workshop and giving a kind of a global overview on Copernicus. I will now turn to our 2 speakers. First, I will turn to the European Environment Agency, where we have Chris Stenmans, who is the agency head of data and information service. So Chris, the floor is yours.
Thank you, Ivan, and good afternoon, everyone. I hope you can hear and see me well. And a big thank you for inviting our agency for this keynote. I will introduce to you briefly some of the main elements of the European Green Deal and the role that Copernicus will play. Can I have the next slide, please? Yeah. So we are facing unprecedented global challenges. And that is well documented in several recent comprehensive reports that are produced by world's leading scientists on the climate change, the biodiversity loss, unsustainable resource use, and environment and health. And they all call for the same. There is an urgency of action needed. They all point to the risk of irreversibility that we are facing, quite a number of tipping points for our planet, and last but not least as well, the problem of the interconnection between all these processes. Next slide. Next slide, please. Yeah, thank you. So Europe has responded to these challenges in the form of a European Green Deal. And as you can see on these slides, there are several high-level objectives with concrete plans. And today's workshop, so we will focus on how Copernicus is contributing to transforming the European Green Deal into action. And it is now already fully recognized that the Copernicus program and its services, that they will be crucial for the successful implementation of not only the implementation, but especially also the monitoring of the European Green Deal. But these challenges, they are very complex and interlinked. And a key message for today's workshop is that it will require an intense coordination amongst many actors involved. Next slide, please. And to understand this complexity, we should first have a look how the policy landscape evolved over the past years. And the EU has been adopting a range of policies which currently form probably the most, it forms the most comprehensive set of environmental standards in the world. And yet, the ambitions set out in the European Green Deal, they are unprecedented. And they put the need for what is called a transformative change to address what we call systemic challenges and to achieve prosperity within the environmental limits at the heart of EU policy. And the result is a new policy landscape, which aims to address the short, the medium, and the long-term time horizon. And that via a range of policies that increasingly connect the environmental, the economic, the social, and the governance dimension of sustainability. Next slide. And let's go a bit deeper on some of the objectives to understand the potential that Copernicus can offer. The EU's biodiversity strategy for 2030, that is an ambitious plan to protect nature and reverse the degradation of ecosystems. Next slide. And the strategy aims to put this European diversity on a path to recovery by 2030. And it contains specific actions and commitments. First of all, to protect nature. 30% of EU's land and sea surface will be protected by 2030. It's enabling a transformative change through promotion of what we call nature-based solutions. There is an EU restoration plan with many commitments, which include, for instance, the restoring 25,000 kilometers of free-flowing rivers, planting 3 billion trees, a new urban greening platform, preserving landscape features, reversing decline of pollinators, and so forth. So quite a very ambitious program. And also an important one is that EU wants to be global leader and is striving for an ambitious global biodiversity agenda. Next slide. And if we take, for instance, the top 3 pressures on biodiversity loss, and they are namely agriculture, intensification or its fragmentation or land abandonment, it's urbanization and it's forestry. And if you take then the land, the marine, the atmosphere and the climate services together, they will be then intensively used to monitor the progress towards the agreed targets. Next slide. And you probably heard already a lot about the attention that is given in the European Green Deal, that Europe is become the first climate neutral continent by 2050. Next slide. And the EU has set targets for 2030 of reducing the net greenhouse gas emissions by at least 55% compared to the levels of 1990 and to reach climate neutrality by 2050. And these targets, they are included in a European climate law. And the current and future Copernicus missions, they will be indispensable for keeping track on these targets. And what also will be interesting for Copernicus is that it will contribute to the new climate change adaptation strategy. And where we have 4 blocks, we are looking for a smarter, a more systemic, a faster adaptation through innovation like Destination Earth, as well as also international actions to address the global aspects to climate adaptation. Yeah, next slide. And you will hear much more in detail about the role of Copernicus during this 2-day workshop with many advanced applications, where Copernicus is one of the many data sources which are needed in combination with many other input data. Like in this example of for the what is called the LULUCF regulation on land use change and forestry. And for the monitoring, the reporting and the verification, the Copernicus Land and Atmosphere Services, they will be used by the member states as well as by the European level as one of the many input data, as you can see here from this diagram. Next slide. And because of the need of a more integrated approach, partnerships will be crucial, and partnerships between organizations which can be public and private. And just to give you an example, in the context of climate change and the link to the impact on our health, we at our agency, we joined a partnership led by the European Commission to establish a climate and health observatory. And the content is provided by many organizations, including Copernicus. And we are hosting this observatory on an existing Climate Adapt platform to support then the European Green Deal. Next slide. And if you take the zero pollution, also with the Vision 2050, it aims to reduce levels of pollution that are no longer considered harmful to health and natural ecosystems. And that within the boundaries that our planet can cope with, and thereby creating then a toxic-free environment. Next slide. And in May last, I think it was in May last year, the European Commission then adopted the so-called EU Action Plan towards zero pollution for air, water, and soil. And this action plan is then translated in specific 2030 targets to speed up reducing the pollution at source. And the Copernicus services, they will be instrumental to monitor the progress towards these targets. And to give you a few examples, it's improving the air quality to reduce the number of premature deaths caused by air pollution, or improving soil quality by reducing nutrient losses. So that is a kind of approach that will be taken to monitor whether we are on target or not. Next slide. And if we take then the farm to fork strategy, that's another cross-cutting objective. And the farm to fork strategy aims to accelerate our transition to a sustainable food system. Next slide. And Europe is aiming for a food system that should make sure that everyone has access to sufficient, safe, nutritious, sustainable food. But it aims as well to have a neutral or positive environmental impact, as well as to help to mitigate to climate change and to adapt to its impacts, and also to reverse the loss of biodiversity. So for instance, if we look to some of the messages that are based on Copernicus data together with other data, that some scenarios, they indicate that climate change impact might lead to a decrease of the agriculture income by 16% in average by 2050. Of course, without considering possible global price adjustments, as we know from these days. And another example is that due to the water shortages, farmland values are projected to decrease in the southern part of Europe by more than 80% during this century. And therefore, in some regions in the southern and eastern Europe, farmland will be abundant. And due to these new economical conditions. Yeah, next slide. So, as a final example, I would like to give a few words about the European Green Deal Sustainable Investment Plan and the just transition. Next slide. So the Sustainable European Investment Plan, it will mobilize the EU funding and create an enabling framework to facilitate and stimulate the public and private investments that are needed for the transition to a climate neutral, a green, a competitive and an inclusive economy. And the plan mobilizes at least €1 trillion of sustainable investment over the next decade. And it will make sure that no one is left behind. And as an illustration, how Copernicus is contributing, so this map, it combines the air quality data with socioeconomic data to show that the most premature deaths due to bad air quality, they are recorded in those areas with the lowest GDP. And so it is clear that a better integration of Copernicus monitoring data with socioeconomic data, that should be a priority for the coming years. Next slide. So to conclude, the potential of Copernicus to support the European Green Deal, it's enormous. And especially to secure what we call at our agency, the continuous monitoring to provide data on the past, the present, and the future across many policy domains. And we at the agency, we are convinced that it's a key instrument that will contribute to what we label actionable knowledge, and which is definitely needed to deliver the ambitions of the European Green Deal objectives and the targets. And my last slide is then just to say thank you. And now let's rush into the workshop. Over to you, Ivan.
Thank you, Chris. Thank you very much. In fact, it was very nice introduction, giving the flavor of what we can expect from the workshop. And I will refer also to your last, before last slide. In fact, the last is thank you. The before last slide, when you were talking about the potential of Copernicus, as we are speaking about Copernicus and the Green Deal, and we are speaking about space. I think it's very important when we speak about space also to have also the European Space Agencies, which is dealing with space in Europe. So I will invite also the director of Earth Observation Program in the European Space Agency, Simonetta Kelly, for a few words as an introduction. Simonetta.
Thank you, Ivan. Thank you, Mauro and Chris, for this introduction. And thank you again for inviting ESA, the European Space Agency, to this important and timely workshop. In fact, I believe that it's very timely because even though we're living dramatic times, it's still very important to recall that we must continue our work for supporting a greener future. The EU Green Deal sets concrete targets. We heard some of those here today, to build a greener Europe, a more sustainable way to manage also Earth resources. Carbon neutrality by 2050, all Europe's ecosystem restored and adequately protected. And we are talking about an ambitious program, of course, here, but the objective is so ambitious that it needs effective support, different tools, and space is certainly one of the tools, and Copernicus is one of the solutions, which certainly is sometimes even indispensable to support such targets and objectives. As you know, Earth observing satellites do provide important information about the state of the environment, the land, the oceans, the atmosphere, and also the interaction among these different elements. Earth, in fact, it's a dynamic equilibrium, and Earth observation provides evidence on how this delicate balance is changing. And the satellites do provide objective information, effective monitoring tools, supporting compliance monitoring, and Green Deal policies, of course. Also, it's not to be neglected that they help to make these progresses concrete, credible, visible, neutral, and also accountable in terms of people, and also very clear for citizens who must support the efforts which are associated to the Green Deal implementation. At ESA, we know very well since a long time the power of Earth observation images to make people aware about global issues such as rising sea levels, melting glaciers, air pollution. So Earth observation data help to provide undisputable evidence to citizens that the underlying efforts make sense and they're paving the way for a better future. ESA is in charge of coordinating the space component to design, develop, and operate jointly with EUMETSAT the Copernicus satellites, Sentinel satellites. And let me recall that today we have a few Sentinel satellites already up and operational, Sentinel 1, 2, 3, 5P, and 6, that provide continuous high-quality data sets and contribute to a number of environmental applications. Soon we'll have also the geostationary Sentinel 4 that will be added to this family, and will give unprecedented high temporal resolution, viewing capabilities on air quality, also met variables. Not only the Sentinels provide useful data, essential data, but we have also the basically numerous downstream services which are fed by this data flow. Really, today we have more than 500,000 registered users. We have 420 petabytes of data downloaded only from the Open Hub. And I will not list all the other uses and advantages that this creates for Europe. The trend is increasing, and basically we can see today that already Copernicus is a fantastic tool in support of environmental policies. So what about the Green Deal? Well, for sure, much is already placed, but there is more that must be done to deal with. We've seen some of the challenges now. We need to provide with additional information. The most striking example is related to the location of anthropogenic carbon emissions in relation to the implementation of the COP21 agreements. But we also have to look at declining ice, melting of glaciers, declining biodiversity, water, food security, and natural resources more in general. This is why, together with the European Commission and also with our region expanding the current Sentinel mission, and we have added 6 what we call the Sentinel expansion mission. We've started to work on those, and we are well advanced. I'd like to mention those Sentinel expansion missions because those are all very relevant to the Green Deal. We have first, it was mentioned by Mauro, the carbon dioxide monitoring mission that will provide consistent estimation of global carbon dioxide anthropogenic emission. This will be crucial to develop and determine emission hotspots, such as megacity, power plants, and also to monitor the extent to which policy measures impact on regional, national, and reduction targets. We also have another mission, which is the imaging microwave radiometer one, which will focus on monitoring Arctic change and support sustainable society in response to the Arctic policy, which is one of the clear policy priorities of the EU. And basically, we have an altimeter also looking at polar ice as no topography. We have then a L-band SAR mission. It's called, this mission has a L-band radar on board, and it will complement the Sentinel-1 radar mission's capability with wavelengths that penetrate also through vegetation, dry snow, and will provide then more accurate estimations of some of the key parameters like ground motion, soil moisture, and land cover. We have also the land surface temperature monitoring mission, which aims at supporting the common agriculture policy, vegetation health monitoring, the thermal stress in crops, and in general, crop and water resources management. And this is crucial for the agriculture policy of Europe. Last, but certainly not least, we have which is aimed at supporting the EU Biodiversity Strategy of 2030. And you may be aware that Sentinel-2 is already an invaluable tool in the family of the operating Copernicus Sentinel satellites to support nature preservation. All these missions, they're not on paper. We started, as I said, to work on those. And last year, we have kicked off the industrial contracts. We are today at the phase where we have started the PDR, so the preliminary design review, early March. They will go on during this year. And basic missions have been approved by member states. And just last month, I want to call that jointly the European Commission and the agency have found an agreement on the way to further pursue this program and the development of granting the integrity of all these missions for the next period, in spite of some budgetary with some budget on this overall. So I really look forward going with these missions to support the Green Deal with the European Space Agency's strong support to the Copernicus in close partnership with the Commission, which is leading it. I would also like to in Toulouse in mid-February, and basically there the concept of the accelerators was a member states, and one of those initiatives on the accelerators concerns Future Accelerator, where this initiative will involve working jointly with partners, including with the European Commission, but also with other stakeholders, also with industry, to find and provide solutions which are space solutions to the Green Deal. And this is something that will also come to complement what's going on Green Deal with the contribution by space. So we're very proud to contribute to this endeavor, to Copernicus more in general supporting the Green Deal. And I wish you then really good constructive discussion for the next 2 days. Thank you.
Thank you. Thank you very much, Simonetta. In fact, thank you for giving an overview of Copernicus as it is today and what will be in the future, and highlighting also the importance of the program. And you gave some examples. I'm sure that we'll hear more examples during this workshop, and I'll be happy really to have a countless number of examples at the end of the workshop, which is very important. So I'm thankful and very glad that we had such a nice introduction by all of our speakers. Now I would like to proceed to the main part of the workshop, which I think is also a very important part. So before we start with the essential part of the sessions, I would just like to say a few words about the organization itself. So we have organized the workshop in 2 half days, 2 afternoons. It was mentioned already. So the first afternoon today, we'll focus more on the, let's say, on the living aspects of the Green Deal, if I can say so, living aspects, in fact, in the how Copernicus can support the Green Deal, addressing mainly the biodiversity, agriculture, but also some human-related policies such as sustainable financing and industry. Tomorrow, we'll focus more on energy and climate, and we'll also address policies like mobility and pollution. The 2 days are split in 2 sessions with a break in the middle, so there will be a short break around 3 o'clock. During the session, speakers will present their experience in how Copernicus supports the related policy areas. And at the end of each day, we'll have a final panel for a short discussion. I would like to tell you or remind you that you'll be able to ask questions online, and we'll try to address them as much as possible, depending on the number of questions. So during the sessions and at the panel at the very end. So you can ask questions using the Slido function on top of your page. We'll get your questions. We'll try to group them if necessary and try to address whatever we can. If we are not able to answer everything, to provide some clarification online, we'll do this also after the workshop or offline also. So I will now proceed with the first session in the agenda, which is on biodiversity. So this session on biodiversity, we have 3 different speakers. We have Blanca Ruiz Franco from the Spanish Biodiversity Repository of Data. We have Martin Herold from the German Research Center for Geoscience in Potsdam. And we have Patrick Lehoudet from Mercator Ocean. So I will give first the floor to Blanca Ruiz Franco, who is in fact the head of the Nature Data Bank in Spain, which is a unit of the Ministry for the Ecological Transition and Demographic Challenge. Blanca, can you hear us, and are you available for your presentation?
Thanks, Ivan. Good afternoon to everyone. Many thanks to the European Commission for inviting us to present the ecosystem monitoring system we are implementing in Spain. Thanks to European funds of the Recovery and Resiliency Facility that will allow us to be better prepared for the challenges and the opportunity of the ecological and digital transition. We have called the system EIKOS, which means in Greek possible, which is not necessarily true, but what has the appearance of truth. Next slide, please. Okay. I cannot miss this opportunity to briefly comment on the Spanish Inventory of Natural Heritage and Biodiversity, established by a national law and regulated by a royal decree. This inventory is a framework that integrates all the terrestrial and marine inventories, including Spanish regulation, 30 components in total. It also established a set of indicators to facilitate the monitoring and interpretation of results. And finally, a 6-year report assessing high adequacy of policies. All this information allows us to comply with the objectives and reporting obligations of both European strategies, biodiversity and forest, the Convention of Biological Diversity and the Sustainable Development Goals. The main Spanish administration with competence in the matter are integrated into a committee that coordinates this inventory. This committee is a group of IONET network. Next slide. Next, please. The information in the inventory is available in an integrated information system called Nature Data Bank. Nowadays, it's essential to reinforce the geographic information. For this purpose, we will develop a knowledge platform with the best geographic information available in the data bank. In addition, the platform will have analysis capacity using new data processing technologies in order to provide a coherent territorial information comparable in space and time. Moreover, continuous monitoring and change alert system, as well as the ability to perform projections and simulation in different scenarios. Next slide. Next. This slide shows the revolution in the data flow. We start with the integration of cartography through distributed edition, faster and higher quality process. Currently, each layer is made manually, gathering data from our autonomous regions and in many cases every year. This data is stored in the system, allowing its interpretation and consultation. Likewise, the system will have the capacity for intelligent analysis and provision of consultation and reuse service, together with interoperability with other external systems, like agriculture land parcel identification system. Next, please. In this slide are the main actions that have been identified to launch this project. I'm going to explain it below. Core IT, data lake, knowledge, and specific application. Next. Different technologies are being used. PostgreSQL database engine, together with its PostGIS extension to improve the available cartographic information, as well as its availability by great number of teams concurrently. Python and R for development of tools that analyze the images of the Copernicus program and cross them with the information of a nature data bank. Thanks to the high capacity of this program language for analyzing large volume of data in combination with a new artificial intelligence tools, improving our data analysis and simulation capacity. To disseminate the data, we will use GIS web technologies such as GeoNetwork for metadata catalog and GeoServer for map web service and REST API service, viewers and dashboard created with technology such as Leaflet. The development of all of this technology will be carried out with the environment offered by Google Cloud Platform, using products such as Compute Engine, Cloud Store, or BigQuery. Next, please. Okay, in the data lake part, the ECOS platform will store the most ambitious set of data describing our territory, represented mainly by in situ data stored in the data bank, LIDAR data with a new flight of 5 points per square meter will be made, remote sensing data, in particular from the European Copernicus program and the use of Copernicus land monitoring service, and also in situ observations. Next slide. The platform will be the catalyst that integrates the various knowledge and technologies for the analysis and exploitation of information that already exists in Spain. To achieve these objectives, creating synergies, identifying common priorities, and aligning the implementation of European funds. To this end, a scientific advisory board is launched. The main objective is to know the needs of the users the platform has to provide a solution to, as well as the partner or global technological solution existing in the academy and business world in Spain. The Scientific Advisory Board will be addressed at first to national research centers and companies in the areas of land use, forest, grassland, and marine ecosystem. Next slide. The first event within the Scientific Advisory Board of ECOS already has a date. It will take place at the end of April at National Center of Environmental Education near of Madrid in Segovia. This event will be a space for dialogue and exchange of knowledge and experience between different institutions and research centers to successfully and jointly face the challenges posed by massive storage, processing and analysis of Copernicus data, its processing in the cloud, and the contribution of the new technologies. Next slide. The platform, in addition to responding to the needs of the General Director of Biodiversity, Forest and Desertification, will be open to other use and needs by external users. Our needs are aligned with the European Union policies, such as Nature Director, or forest management, or ecosystem accounting, or green infrastructure. The user needs identifier in the advisory board will also be taken into account. Next, please. Yes, the most important product of the platform is the creation of an anomaly and early alert module for the detection of change in nature ecosystem. In addition, it will have a concrete application in the management by updating the national thematic cartography through semi-automatic process, like, for example, Spanish forest map or ecosystem map. Moreover, process simulation and analysis of the effects of climate change. And finally, we want to explore its application in the development of virtual models, digital twins, oriented to decision-making in specific areas of our territory. Next, please. The purpose of the Anomalies and Early Alerts module is to develop a system for monthly detection of anomalies and alerts, thanks to a traffic light system caused by sudden change in vegetation. Access to Copernicus data will be made by connecting the platform to the online image catalogs and cloud processing service of Google Earth Engine, where the selection, filtering, and processing of the Sentinel 2 historical series. From this data, various indices related to the vegetative activity, NDVI and other, will be calculated, which will be stored on the platform for reuse. Together with historical data, the reference conditions that synthesize the dynamic of the vegetation throughout the year will be established. These anomalies will serve as the base for the generation of a monthly alert on ecosystem, combining with information from the Spanish inventory to build the logic of the traffic lights. The alert will be integrated into ECOS MES and code using a system of traffic lights colors: green no change, yellow possible change, and red change. Anomalies and alerts will be made able to users of the system through the viewer, as well as for consultation and analysis through different tools. And the last slide, last one. Okay, now thank you for your attention, and thank you for attention. Over to you, Ivan.
Thank you very much. Thank you, Blanca. So interesting. I will move now to the next presentation, and then I remind to the audience they can ask questions. So if they have any particular questions, especially for some of the speakers, please put also in your question the name of the speaker you would like to ask the question, if it's addressed to some of the speakers. So now I will introduce Martin Herold, who is a professor and section head of remote sensing and geoinformation in the German Research Center for Geoscience in Potsdam. So Martin, it's up to you.
Yes, good afternoon, everyone. Thank you for the invitation. Can you hear me well? I see you nodding head, that's good. And hello to everybody who's out there. I'm going to give a quick overview of forest monitoring progress and prospects for a Green Deal and for the Green Deal. Moving on to the next slide, we already know that Earth observation has contributed a lot to forest monitoring. In fact, what we know about the world's forests and its changes and where it's changing and why it's changing, we mostly know also from the use of Earth observation data. There are a series of large area data sets derived from Earth observation to really tell us about the types and the magnitude of changes we have been seeing, including those coming from the Copernicus program. People and users of this kind of information really value the open, transparent, and spatial quality of the data and information. And it's not only on the global level, but also countries are using Earth observation data for the national forest monitoring and also increasingly for their greenhouse gas inventories. So moving on to the next slide, we were quite happy to see that in the last round of FAO's Global Forest Resources Assessment, many countries are now using remote sensing for reporting on their forest, and we've seen a particular uptake of this kind of information for African and other tropical countries over the recent years, where we see that a partnership between experts in the Earth observation field and country stakeholders and experts can really work together to improve these capacities. Next slide. In a recent completed Copernicus project, it's called Red Copernicus, that defined and scoped a new global Copernicus forest and RED+ monitoring service based on a quite thorough policy review and stakeholder analysis to assess what is needed in terms of future forest monitoring, and we match that with available capacities in Europe on providing these information. We developed basically a new design of such a service that's available now, and I think there's a plan also to roll that out over the recent years to really make use of Sentinel-1 and Sentinel-2 data in particular for improving global forest monitoring. The policy requirement analysis and stakeholder analysis underpinning that is now 2 years old. That's how projects go. And we know with the Green Deal, which just recently surfaced, next slide, we also see some additional new challenges that are coming up. For example, this link to the bioeconomy. We see the need to incorporate more biodiversity and climate objectives in managing forests. We see this need for more transparency, particularly for critical forest changes in the context of sustainable supply chains to essentially avoid a brown deal and to actively support the implementation of sustainable and climate smart forestry and land use. And Copernicus can deliver towards that with the timely availability of data, having spatially explicit data, and having data that are in fact actionable. And we've already seen some of these examples until now. What's very important is that Copernicus capitalizes on both space-based and on-the-ground data streams. These on-the-ground data streams can come from national forest inventories, they can come from citizen science networks, they can come from research plot networks, and really it's the integration that really help us to move forward on many of the challenges we have here and serve a broad range of users and stakeholders from such data. To get a bit more detailed, next slide, please. There is a proposal for regulation under the Green Deal on a deforestation-free products trade. And that proposal actually poses particular challenges also towards Copernicus for actually then checking on how deforestation-free supply chains actually are. So any operators providing certain commodities can use science and technical means to assess the deforestation-free nature of their supply chains, and Copernicus already referred to in that context. And this can be related to wood supply, but also to commodities such as cocoa, oil palm, and soy. There's also national rates of deforestation for focused forest degradation, which can be observed from Earth observation data, are among the list of criteria for benchmarking exercises as currently laid out in the proposed regulations. And so with these regulations on the horizon, next slide, please. It's clear that we have to move with Earth observation data, not only looking at forests, but also at land use affecting forests. and with new approaches, for example, coming from artificial intelligence, we can move forward on more monitoring of land use and land use change and tracking human activities that are affecting forests. And that is really at the core on what the Green Deal is going to achieve, to change land use practices and improve land management for more climate smart and sustainable development. We've already seen, next slide please, that remote sensing can help us to understand harvesting and harvesting dynamics. In this case, this is an example of Europe. This analysis also prompted a discussion to again emphasize the need that these satellite-based observations have to be integrated with on-the-ground data and harvesting statistics to really get, let's say, an integrated monitoring of these kinds of processes. And then next slide, we also see improvements in the monitoring of the above ground biomass and carbon stocks of forests. Also here satellite data, in particular satellite data that give us information about the third dimension, such as those coming from radar or LiDAR, really help us a lot when we integrate them with ground-based data to get a global picture on above ground forest biomass and biomass changes. This is an evolving field. We have a European biomass mission. It's actually called Biomass Mission that's being planned to be launched. And these kind of data will serve the monitoring of these kind of purposes. And we've just very recently, next slide, seen how Copernicus, and this analysis is based on Copernicus data, is providing these timely data. And these are basically weekly or monthly to weekly observations of, in this case, forest logging activity in the Congo Basin on the left-hand side. On the right-hand side, you see shifting agriculture patterns, so it's the same region, to really track human activities affecting forests, and not only that the activities are happening, but also to give an estimation of the local carbon losses associated with these activities. This is a local example, but in fact, this prototype system runs for all of the humid tropics of Africa already, and is a good case where we see if you have timely data, if you have transparent observation, you can really track activities and enforce any potential illegal or unwanted behavior with that kind of information over very large areas. Next slide. We are also then, of course, seeing what's possible today, but also have an eye on preparing future Copernicus capabilities. There are other Copernicus, or the next generation Copernicus, already on the horizon, providing hyperspectral data. And hyperspectral data, I think, will really be a breakthrough when it comes to the assessment of forest, species, and biodiversity characteristics, which we still have limitations today. We have an L-band radar system, which really gives us information about forest biomass and structure, and in particular also can improve this near real-time alerting, because radar data has cloud-free capabilities, meaning that we're not constrained by cloud coverage. And also thermal data, where we really have to, we're all looking forward to an improved assessment of particularly drought, stress on drought impacts or climate change impacts on forest, what we still currently struggle to assess on all level of detail. So there is basically ongoing capabilities in Copernicus today, and then we move on to the last slide that we can build on today. There is services available building upon Sentinel 1 and 2. I think we are ready to develop additional capacities for the Green Deal topics, which I'm looking at not only forest, but also land use and land use change and human activities affecting forest, monitoring, zero deforestation, sustainable supply chain for the various commodities, the rapid alerting of critical forest disturbances and enforcements towards the estimation of forest biomass and greenhouse estimation, and combining on-the-ground and space-based data. And last point, to really get ready for the future Copernicus capabilities that we'll be having in the next few years, and where I think additional partnerships with the research community are needed to really capitalize based on those developments. With that, I would like to close. Thank you very much.
Thank you very much. Thank you very much, Martin. So that's interesting. I think thank you very much for providing this presentation. I will move now to to the last speaker in this session. And I see that there are already some questions in the chat. So if you have other questions, please don't hesitate to ask. We'll try to address them at the very end of the session. So now I will turn to Patrick Lehoudet from Mercator Ocean. Patrick, the floor is yours.
Thank you. Thank you for the invitation to give a presentation to this workshop. So I will give you an overview on the ongoing and coming work of the Copernicus Marine Service regarding the monitoring and forecasting of key ocean variables for marine species management and conservation. Next slide. So we know that we are currently facing a series of serious challenges regarding the management and conservation of our oceans. It has been said already, there are multiple sources of pollution, habitat degradation, plus the exploitation and sometimes overexploitation of resources, and the new coming challenges linked to the issue of climate change. So obviously, all these issues will have consequences on the biodiversity, the productivity of the ocean, the ecosystem structure, and finally the carbon storage by the deep ocean. So to help managers and support better governance, we need more knowledge, of course, and also better or new tools to facilitate answering multiple questions and easily test various scenarios. Next slide. The Copernicus Marine Service is just entering its second phase. And one key objective for the coming years will be to deliver improved and new ocean essential variables to support the management of marine resources and the conservation of biodiversity. Next slide. A classical approach to study marine species ecology is to define species habitat. Most often, marine biologists start from a data set of georeferenced presence absence for a species of interest. And by crossing this data with a series of environmental variables that are supposed to be essential to the species, it is possible to get a statistical relationship or model to predict the species distribution. Three variables have been particularly used by biologists in the last 2 decades: the sea surface temperature, the sea surface chlorophyll, and the sea surface height. Next slide. A nice application, for instance, is provided by Elliot Hazen and his colleague from NOAA. They effectively use these three variables plus the bathymetry to predict the habitat of these 5 species that you have on this slide. So one species is exploited, the swordfish, and the 4 others are protected species with different degree of risk in terms of conservation. So once they get the habitat for each of these species, they propose to combine them with different weights according to management objectives and to use it on a day-to-day basis as a management tool to avoid bycatch of protected species. Why do they choose these variables? First, because they are synoptic satellite data, so meaning global with no gaps, or if there are some gaps, they can be interpolated. They are available over a sufficient long time series. And of course, they can be assumed to be essential for the species, but maybe not directly. Chlorophyll A, for example, is used because it's assumed to be a proxy of prey abundance. And sea surface A is assumed to be also a proxy where the prey can be aggregated by the mesoscale circulation. So they use this proxy because there is no choice. And by the way, you will note that the most informative variable in this case is still bathymetry. Indeed, the level of correlation in this type of studies is always very low. Next slide. The reason is that proxy variables can mismatch some key patterns of the real variable of interest. For instance, when we assume that surface chlorophyll is a proxy of zooplankton, there are two potential sources of mismatch. In cold marine systems, the peak of abundance in zooplankton is delayed in time by several weeks relatively to the spring bloom of phytoplankton. This is not the case in warm tropical systems, where the seasonal signal is much weaker and the development of the plankton follows almost immediately the primary production. But here, the mismatch comes from the maximum chlorophyll that occurs in subsurface and is not visible by the satellite. You see this very clearly, this deepening of the maximum chlorophyll on this transect on the bottom of the slide, with a transect starting from the cold waters in New Zealand to the warm tropical system in Tahiti. So the maximum chlorophyll occur below 100 meters in the tropical areas. The next slide. So the solution is first to use vertically integrated primary production instead of surface chlorophyll. And second, to propose the true variable instead of the proxy. In that case, zooplankton. Total primary production is now available either from empirical models based on satellite data or biogeochemical models that are becoming more and more accurate thanks to the use and assimilation of both satellite data and in situ data like the BioArgo profilers. For zooplankton, it is impossible to propose a synoptic approach of observation, so we must rely on modeling. But here we can take advantage of the progress achieved in the simulation of physical and biochemical ocean models at high resolution and with massive data assimilation. This model should progress rapidly, and the first products are made available in the Marine Service Catalog. Next slide. Other new variables are or will be proposed: dissolved oxygen, pH, particular organic carbon, or my favorite, the micronewton biomass. Micronewton is composed of a myriad of species, small-sized species, shrimps, fish, squids, and they are the prey of large marine predators, like the two species you have, example you have here. One elephant seals from the Kerguelen Island in the Southern Ocean, and one big-eyed tuna in the Atlantic. These both individuals have been equipped with sensors allowing to demonstrate that they spend their time to chase mesopelagic micronewton in the subsurface, and a large part of this prey species are migrating vertically each day and night. Next slide. As for zooplankton, we need to rely on modeling to propose biomass distribution of these variables, prey species, with, of course, necessary simplification. For instance, using several functional groups defined on the basis of their vertical migratory behavior. The first reanalysis is available now on the Marine Service Catalog since 2 years, and the number of published studies using such new essential ocean variables is growing. Next slide. Next slide, please. There are a few examples here dealing on the diversity of species from krill to whales. And in all these examples, the zooplankton and or micronewton seem useful to solve the lack of direct observation of prey or predators abundance. Because the micronewton can be also the predator of smaller organisms. The particular organic carbon or the marine snow is also a useful variable to get a better prediction of abundance and species richness of the deep ocean fauna. And as highlighted by the small mosaic of pictures in the corner, each of these studies can be associated with economic and or conservation issues. Next slide. My last example is more directly focused on fisheries with a fish and fisheries model developed here for tropical tunas. This model that can predict detailed abundance by age group of a given fish tuna species is using several key ocean variables, which are listed here and available through the Copernicus Marine Service. This model is used either to test various management scenarios, for instance, the impact of large marine protected areas in the ICs, but also to explore the future impact of climate change on the tuna stocks, the fisheries, and the economy of the Pacific island states. Next slide. So as a conclusion, the roadmap for the coming years for the Marine Service will be to continue to provide the existing essential ocean variables with higher accuracy and resolution, and to propose new ones, as I've shown previously. In parallel, there is an interest to add seasonal forecast and multi-decadal projections, including climate change scenarios, to the existing products of reanalysis, real-time and short-time forecast. Thank you very much.
Thank you. Thank you very much, Patrick. Very interesting to see also a little bit, let's say, the other side. Usually we talk about biodiversity on land and probably less frequently on maritime. So I would like to thank you all for your presentations. It was very nice. We have a few minutes for questions, so I can probably maybe proceed with questions. I saw there were a few questions for Blanca. Maybe I can start with one which I find really interesting, Blanca. So it was Emmanuel Mondon who is asking that one of your 4 applications described in the presentation is development of virtual models on digital twin. So are you planning some leveraging also with Destination Earth?
Thank you for this question. We are collecting all the knowledge that we are now existing in Spain, and of course we will use the service and project of a European or other project, and I hope to use this project. We need to learn about all of that are existing.
Okay. Then maybe we can proceed with few other questions. I would say there was one also again from Emmanuel, who is asking about if you have any plans to move to DS, because you were saying that you use Google Cloud and Google Earth Engine. Do you have any idea about if you have plans to move to DS and use DS in the future?
Okay, we analyze of all the solution, the technical solution, and we hope to use Google Earth Engine because this system is used in for our colleagues of agriculture land system parcel for agriculture, and we want to interoperability with this system, and for this reason we use the same technologies.
Okay. Thank you. Okay, very good. I just wanted to ask also a question, probably the other participants. I was wondering when I was looking at the Martin's presentation, you presented a very nice animation on logging. And I was wondering if you have any particular application of the results. Well, you said that it runs already in Africa. Do you have any, let's say, specific examples of how this can be used, or it was already used in some particular applications?
So yeah, so there's a couple of ways this information is used. The value really is, as I said, it's relative rapid information, so it's often also called alerting. I think also Blanca was referring to that. It's used, for example, by environmental NGOs to, for example, look at illegal activities in forests and protected areas, for example. We also see it used by commodity companies to track what's happening in the forest in their concessions or surrounding their concessions, also surrounding their, for example, oil palm plantations and these kind of things. So they want to keep active track on what's actually happening in, for example, forests that are not supposed to go under, for example, active human interventions. In Europe, for example, that's perhaps not something I would say there's an active use. We now, I think, developing these kind of information to really track disturbances relatively quickly, in particular to look at what are climate-induced disturbances. Now, for example, the impacts of drought, we've seen a massive impact of those, but also to look at, for example, harvesting or other kind of activities, separating the two and getting up-to-date numbers on what's happening there. And, let's say, target certain field interventions or additional field measurements also as needed.
Okay, thank you, Martin. That's really interesting. Okay, I just one question also, if I can ask Patrick, because you were talking about the different essential variables that you are using, but I wonder if what else can be needed. Let's say a bit of a theoretical question, just like imagine what can happen is that what else can be needed from Copernicus to support other essential variables that I guess you have already some ideas today that's for variables that are probably not very much supported, but maybe supported in the future. Do you have any ideas?
Many. Thank you. Well, the problem with the ocean is it's not only the surface. So we have the satellite to see what's occurring at the surface, which is already great. And we can use this data to assimilate the information in ocean models. And the problem is we really need also the in situ observation and a very strong effort, which already exists, but we need to continue to improve the observation of the inside of the ocean. So not only the physical variables or the biochemical variables. Now there is the new profile BioArgo floats that are providing very nice information, for example, on the deep chlorophyll maximum that I presented. But we need also information on the biological components, so the zooplankton, the microplankton, and all this information need to be included, assimilated in accurate physical models to provide the global vision that we need of the biological component of the ocean. So we need a strong effort to continue the effort on the observation, not only the satellite, the space observation, but also the in situ observation, and both for physical, not only physical and biochemical, but also the biological components.
Okay, thank you, Patrick, because I think it's very important not only to see what we have, but how to dream a little bit and probably see the future. That's in fact the idea of this kind of workshops also, is to share and understand. I would like to thank you, three of you, for participating in this session. I think it was very interesting and we tried to cover as much as possible. It is very difficult, in fact, to cover everything, because I had probably to start with this from the very beginning, covering all the policies in details for Green Deal and what Copernicus can contribute to the Green Deal. It's very difficult exercise. So we try to give some kind of a flavor here for the different policies. So this was about biodiversity. I will now move to the next session, which is more on agriculture, or the farm to fork, as we call it. So in this session, we will have three different speakers. We invited Antonio Graça from Sogrape Vinhos from Portugal. We have also Claudio Lazabal from the European Commission DG Environment, and we have Han Wensik from Netherlands, from the Geo4A company. So I will start with Antonio Graça. I understood, I don't know if your presentation can be shared finally or not, because I think there were some some glitches. It may be not, because I understood that there was an issue with the technical issue. But if not, maybe Antonio, you can probably give a kind of introduction. How do you use Copernicus in your cases? Thank you.
Yes, good afternoon, everybody. First of all, and thank you very much for the invitation to be here. I was being messaged by Brussels saying that they do have my presentation. So they could either, sorry?
Yeah, Antonio, you can share your screen, that's fine.
Okay, then I will share it myself. Just bear with me a second, please. Well, actually, it seems like I am not allowed to share. Are you sure you have allowed me to share? I get a message saying that sharing is not activated.
Share it for you.
Okay, that's perfect. Beautiful. Okay, so sorry for this small mishap. We can move on to the next slide right away. So just for a quick introduction to who we are a wine producing company from Portugal, actually the largest in the country. It's a family-owned company. We have vineyards, also about 1,000 hectares in Portugal, and also 600 more hectares of vineyards scattered between Spain, Chile, Argentina, and New Zealand. So we have a global footprint. We have a very good understanding as to how environmental conditions will shape the quality and composition of our grapes, and therefore the quality of the wines we can derive from there. It's also important to let you know that for us, wine needs to be responsibly consumed, and that also is integrated in the type of management we do in our vineyards, and the precision that the growing precision that we apply in that type of management. Next slide, please. So in terms of the context we are evolving today, it's a context characterized by high volatility, both from environmental pressures, but also from market pressures, together with growing competitiveness from different areas of the world. Wine has become a global product, and it is not just distributed across the world, but also understood in many different ways across the world. Next slide. In terms of growing grapes and cultivating this crop, we have moved several years ago from a management that opposed nature to a management that has and uses synergies with natural processes, trying to use as much as possible nature as a function and as a service, but also as a positive contribution to the final outcome. Next slide. Of course, today we are facing challenges from climate change, but not just climate change. But these challenges increase the variability, increase the diversity of situations we are facing. And for example, on this slide, these were our pictures taken exactly in the same place with 6 months difference. And you can see that we went from a very extreme winter situation to another extreme summer situation. It is this type of wide variability that our production systems are being faced today. Next slide. Of course, today we are also moving on to a more integrated understanding of how our operations interact with the wider society. And we are, of course, getting our own management more and more in tune with the social and societal guidelines that have evolved. And today, sustainable production is a key issue that has come to systematize and organize a lot of the processes that we already had in place, because especially for family companies like our own, sustainability is always a key issue in terms of transgenerational transmission. Next slide. So Copernicus come in with a lot of data that we integrate in the processes we use for managing this complex situation in addressing sustainable production. This is an example of information that we are using together with a startup company in Portugal in order to schedule protection treatments for grapevines in a way that we will not have a loss of those products onto the environment. For example, on this chart on the left side, the blue bars indicate an hourly forecast of rainfall that shows us that in this week we should not schedule a treatment on the first 3 days, but rather schedule it on the last 2 days, and therefore avoid a washing of that the protection products onto the environment with a natural impact, but also with costs. So this allows us to position our operations in a more sustainable way, both economically and environmentally. Of course, we need information from our local weather stations, as you can see in this picture, but we need it coupled together with the wider information that we can get from ECMWF and the Climate Change Service of Copernicus. Next slide. Also, in terms of projecting evapotranspiration to manage the way we schedule irrigation and the way we use water in an approach that requires the minimum necessary amount of water for the highest possible effect in keeping the metabolism of the plant working and providing the type of grape composition and quality that we need. Next slide. Another issue that we are using more and more is the coupling and the fusioning of data from Sentinel satellites, in this case for NDVI, but we also use it for red edge measurements, in terms of increasing the granularity, the temporal granularity of the information for vineyard management. So we use once a year drone assessments and the weekly Sentinel lower spatial resolution assessments in order to monitor what is going on in terms of canopy development and identification of heterogeneities or any other accidents that may arise from deficient nutrition, lack of water, or specific climate extreme events. Next slide. We're also using information from current land cover, for example, in order to determine the distribution of vineyard area across the country. And this was used, for example, to make an assessment of the production of vineyard subproducts as opposed to processing facilities across the country, and also taking into consideration the road network and the railway network in order to understand where would be the most likely or the most efficient positioning of a production facility meant to transform vineyard byproducts into new raw matter that could be used either for energy production or for biomaterials to be used either on our own sector or in other sectors. Next slide. More recently, in a project that was funded under Horizon 2020, we have developed, together with 15 other partners in Europe, a system that it's actually an ITC platform that gets data from Copernicus Data Store converted it into indicators that are relevant for the wine industry, like, for example, growing season average temperature, or spring rainfall, harvest rainfall, number of days above 35 degrees, and allows it to derive seasonal forecasts for the next 7 months, which help decision makers in our processes to define which type of planning they will require as a function of expecting higher than normal, lower than normal conditions for both temperature, rainfall, or other situations. Also, on the right side, we see a declination of long-term projections for the remaining part of our century on the Douro region, where we produce port, of areas, which are the ones on red, that will have the growing season average temperature above the highest limit for the grape varieties that are grown there, and therefore regions that are bound to become just too warm to produce quality wines. Next slide. So wrapping it up, Copernicus is becoming a real important global asset for sustainability in the wine business. This is something that has been widely recognized by the International Organization for Vine and Wine, but also integrated in our global program for sustainability across the different geographies we operate. And in this way, providing a more sustainable production of wine. Next slide, please. So finishing my presentation here today, I just would like to say that wine is one of the situations, one of the crops where most of data of Copernicus has been made into use to have both the crop and the landscape and nature management organized in a way to provide a future, not just for the business, but also for the economies and the communities around the business. Next and last slide, you can see my contacts. I'll be happy to answer any questions, either here or later through my contacts. Thank you very much.
Thank you very much, Antonio. It's very, very interesting. I think it was excellent to see the different applications of Copernicus. That's right that it's applicable to grapes and wine production, but it raises also the question if this cannot be applicable to any kind of any type of crops, and I believe that's the case. But we are happy to have you here to give this concrete example. I understood that you'll be not able probably to stay until the end of the session.
Yes, I can stay for another 20 minutes max. That's all.
Okay. So if there are any questions coming to you during these 20 minutes, maybe we can address them before you leave. If not, I will transfer these questions to you and we can answer them offline.
Thank you, Ivan.
Thank you very much. So now I will move to the next presentation, which is given by Claudia Olazabal. Claudia, she is the head of unit in the land use and management unit in the European Commission, DG Environment. So Claudia will be happy to hear from you also. Thank you.
Good afternoon. Thank you, Ivan, and thank you very much to the colleagues of DEFIS and the EA for inviting me. I'm very excited to be here, and I think it's very nice to come right after the biodiversity strategy and the presentation of Antonio, because in reality, what we are aiming at with both the biodiversity strategy and the farm to fork is to really strive for sustainable agriculture and sustainable food chain in general. And if you look at the whole range of the farm to fork strategy, which has been several slides have posted it, really where Copernicus would have a huge potential to help and support that policy area is on the primary production part. We have, of course, after the food processing, after the consumers and the dietary choice, choices and the behavioral changes, that's perhaps less where Copernicus can help. But in terms of what the land use would be in the agricultural phase of the farm to fork, the potential is enormous, and Antonio has just for one crop show the enormous amount of things that can be done, and for which the data from Copernicus could be essential. We have to move, and we have moved with the Green Deal away from just looking at highest yields and highest production, and to have a much more integrated notion of what agriculture should be in terms also of the resilience of agriculture in the longer term, and also on the use of natural resources and the link with nature and ecosystems, which are at the basis of the production capacity. So in that sense, the hunger of policymakers, if you were asked policymakers, which is my case, what would you need from Copernicus? Our hunger for data is limitless. So we would come with a huge list of things that we think Copernicus can give us. And then, of course, we need to have the reality check of what Copernicus and remote sensing can give us. But the expectations on policymakers and our discussions with member states and with stakeholders of the expectations that we can get from remote sensing, and Sentinel was already mentioned and has already been providing a lot, and Copernicus is already providing a lot. And we think really that we haven't untapped the whole potential. And so sometimes we are a bit unrealistic of what Copernicus can give, but we really think it can really make a huge difference. When we talk about agriculture, of course, we talk about soil, we talk about the biodiversity, agrobiodiversity, we talk about landscape features, we talk about farming practices, and those are often very expensive and complex to monitor in situ and on the ground. And member states, when we ask them that data, they sometimes say, well, okay, your hunger for data is enormous, Commission. You need to be a bit more realistic compared to what can be in terms of costs. And that's why the Copernicus comes in everybody's mind as a bit the savior of that dilemma in terms of cost of on-site monitoring. So we have in the farm to fork, we have a number of targets, which are, by the way, the same targets that you will find in the biodiversity strategy. One is 25% of organic farming, 25% of the agricultural land in the EU under organic farming by 2030, 50% reduction of nutrient losses into the environment by 2030. We have also the target on 50% reduction on use and toxicity or risk of pesticides by 2030. So we have a pesticides, we have a nutrients target, we have an organic farming target. Then we have also an antimicrobial target in the farm to fork, which is clearly one that can less be looked at through Copernicus. And we have one that it's in the biodiversity strategy, which is not in the farm to fork, which is the 10% landscape features in agricultural land. And the one of landscape features in agricultural land that has been one very debated, but one where we really need Copernicus to map these land-lying fallow and these landscape features, which are absolutely crucial for biodiversity and raising or changing the very alarming negative trends of biodiversity in farmland. So there we need these spaces for nature, and where are those? Are there those in the most intensively managed areas? Where can we put those? And there Copernicus could be of huge help. We also have these, as I said, nutrients and pesticides. So we all have the reducing inputs part, also a more efficient use of resources, be it inputs, be it fertilizers, be it water, be it pesticides. And there again, data from Copernicus, just as has been shown by Antonio, can be extremely helpful for not only policymakers, but also to land users. And also Mauro mentioned at the beginning, also for researchers. So, I mean, there's a whole panoply of land use of users of the data that can make the most of the data in order to improve agronomical practices. And there, if you see the farm to fork, there's a big push for agroecological practices. And by agroecological practices, instead of, as Antonio was saying, working against nature, is working with nature and making nature work for us. So in that sense, it's mimicking a bit natural processes with a bigger diversity of crops and management types within the same areas. And that again could be facilitated enormously by data coming from Copernicus. Another thing that is very much pushed is carbon farming. So we want to, of course, we need to suck up CO2 from the atmosphere. So we want to sequester carbon in the natural system, be it soil or forest. And there again, we are hoping that the carbon stocks, the follow-up on the carbon stocks, of course, they will need to be measured in situ, but that data coming from remote sensing could also help into following the carbon stocks of our carbon sinks, which are becoming increasingly important both for mitigation and adaptation to climate change. Water availability, a crucial problem, particularly in some areas in Europe, and I'm thinking about the south, but not only, where this is going to be increasingly a problem, and which could hamper agriculture, but not only agriculture, but also other practices or other sectors. So there again, Copernicus would be an extremely useful tool for forecasting. Then, as I said, also policymakers, we want the data for making policy, also for measuring whether the policies which we have already taken and we have already decided, whether they have been efficient in providing the results we wanted them to provide. So in terms of allowing us to have a mechanism to check how good or bad or how adequate the measures we've taken have delivered. And also in order to, as I said, improve our knowledge about the system, because we know a lot about soil and we know about a lot of water, but there's many things. And what we always are very eager to know, and both of the colleagues in agriculture as well as in environment, is the cause effect. So what is the cause of a certain agriculture practice? What is the effect on the water? What's the effect on the soil? What's the effect on pollinators? What's the effect? And whether when we have a problem, when we see a decline on certain species or decline on soil fertility or carbon stocks, what are the practices that led to this, or what are the factors that led to this? And there are so complex these ecosystems that to understand the cause effects, which are at the heart of what we are trying to solve, or at the heart of policy making, the amount of data we need is enormous. And there again, that's why our expectations that Copernicus would help us in this complex cause effects is very high. Also in terms, we use it also in terms of compliance. We don't want to be big brother, but there is, of course, very clearly for policymakers a clear compliance check role of Copernicus, and be it under the CAP, where there are some obligations for the farmers or some contractual obligations, or be it through environmental legislation. There are some obligations which need to be respected, and whether they are respected, that's something that we are very eager to have the support of Copernicus. And in that sense, also in the Common Agriculture Policy, in the new one, there's been a clear encouragement to member states to follow up and enforce the controls of the cap, not only by sending inspectors, which was the traditional way, but also to use remote sensing capabilities to control and reduce the cost of inspections and controls on the cap. And then the researchers are key, because if we want to shape new measures or new interventions or new things that can be paid by the cap or that need to be in environmental legislation, we need science to make sure that we get the right measures and the ones that are going to deliver. And for that, we come to the researcher side, where indeed researchers can be the best and the most equipped to assess the data, because this enormous amount of data that Copernicus can deliver needs to be properly assessed and translated into a language that policymakers can understand and make something out of it. So in that sense, both with biodiversity strategy and for the farm to fork, as I said, there are huge expectations on how Copernicus would be a massive machine for delivery of this very systemic and holistic strategy. And I will finish by just mentioning that in the forest strategy and in the soil strategy, which I haven't mentioned, but it's are two also spin-off of the Green Deal, we announced two new laws. One on forest monitoring and strategic planning, and one on soil health for next year. So there will be one law on forest and one law on soil health. They have different scopes, and I will not get into the details. But imagine we are now really trying to legislate really on big environmental media in the terrestrial environment. And you can only imagine the whole expectations and the role of Copernicus into delivering data, but also assessments for these two laws, which we will be developing, and for which we hope that the member states will be implementing in the next years, and we will be catering for two big gaps that we have in environmental legislation at the EU level. So there again, I'm just coming with a lot of requests and a lot of wishes, and a lot of responsibility for the colleagues dealing with Copernicus and all the other colleagues of also the European Space Agency, on how much we are expecting your work and how much it can help us. Thank you.
Thank you, Claudia. In fact, you are welcome. The expectations and the wishes and the requests are welcome. That's the idea. In fact, I have just to mention that we are working also in parallel internally in the Commission to try to address all of these aspects. But as you say, it's a huge. I think you gave a quite a comprehensive overview of the different aspects, in particular the policy making aspects. And there is a lot of work to be done there. That's for sure. I will now move to the next speaker, and then we'll come after that to some questions. I will invite also Han Wensik from Geo4A from Netherlands, who is in fact a non-executive director in Geo4A, and who is, in fact, Geo4A is a company aiming at supporting and optimizing the global agribusiness value chain through innovative satellite-based solutions. So, Han, it's up to you. We'll be happy to hear from you too. Thank you.
Okay, thank you very much, Ivan, for giving us the opportunity to give this presentation here. Yeah. Next year, it will be 40 years ago I started to get involved in space technology and space applications. Since then, I have seen many developments and many changes. I remember the first European remote sensing satellite, the ERS-1. And in the mid-90s, when we were interested to use the data for applications, it was almost impossible to get access to the data. And even in case we got access to the data, there was a price mechanism implemented, which makes it really impossible to build business on top of that. I remember in those days, it was pure a technology push environment with the goal to develop and to launch satellites. And use of data was a second or even third order priority. So I'd like to congratulate and to acknowledge the European Commission as well as ESA for being so successful in making the transition from a technology push environment towards a data pool, data use and service environment over the last 25 years. And I think, and I will show that the CLMS is, in my view, a very nice example of such successful change. In my presentation, I will show that a public service like the CLMS is an important development for also commercial applications in the agricultural sector, but also beyond that, and that it will support business all over in Europe. Next slide, please. In my presentation, I will give you a background on the potato sector, our company, and typical examples how the CLMS is used in the potato business worldwide. I will end my presentation with an outlook to the future and an invitation to organizations to work together with us with the goal to develop further an efficient and sustainable service sector in the agricultural sector. Next slide, please. The potato market is huge and a growing business. There are companies serving the market vertically. These are, for instance, companies involved in weed killing products, machinery, companies providing fertilizers. We are not focusing on this part of the industry. We are focusing on what is called the horizontal market. These are companies involved in breeding, trading, and providing value-adding potato products like chips, fries, as well as organizations who are monitoring and enforcing breeders' right. Breeders' right is a kind of intellectual property right, and parties involved in the food security. Our company is an SME, started a couple of years ago, but successful and trying to develop in the next couple of years a huge market. And I will show you examples in the sector which we are providing at the moment. The next slide, please. Our business strategy is very straightforward. We need to understand the potato sector, our clients, and their key challenges. It is a very interesting market because the business of our clients is very challenging. On one hand, they need to understand their clients and the products they require. On the other hand, the products they provide are not yet available because they need to be produced in the next half year or the next year. And these products, because they're not ready yet, there are a lot of uncertainties in the quantity of the potatoes, so in their products, as well as in the vitality or in the quality. And it makes it very interesting to get involved in this type of business. So if you look to the business strategy, as what I said, is there are a lot of uncertainties in the business processes of our clients. And what we are trying to do is we're trying to help them to improve the efficiency and to stimulate sustainability. So we try to reduce the uncertainty in the growth process of potatoes, in quality and in quantity, and and also in the efforts to monitor and to reduce the impact of having made wrong decisions. So to make it very clear, sometimes you offer a lot of potatoes, and there might be problems with these lots of potatoes. And what you're trying to do is you are trying to reduce the claims getting from your clients. How are we doing that? We are involved in mathematical modeling of plant growth and plant vitality. And we are using observations. So the CLMS is an important source for us to reduce the uncertainties in these models. Our core activities is plant modeling, but also data quality control and the monitoring of environmental conditions, specifically looking to the soil, but also looking to the environmental, to the weather data. And based on that, we're developing these, what I call automated applications. Our organization is a very open organization, partnerships with high qualified staff, and we're trying to automate the processes as much as possible to bridge the gap towards the potato industry. Next slide, please. The seed segment is very interesting. It is a huge sector, and if you look just to the top 20 companies in Europe, they have a turnover of more than 1 billion, and they're producing each year about 1.3 million tons of potatoes. Most of these potatoes, of these seed potatoes, are exported worldwide. But also the same companies are involved in breeding new varieties. And why? Because they want to get a high utility value. They want to connect them to new areas. You can imagine that in certain continents like India, they require other type of potatoes than, for instance, in Africa or in Europe. And they're also dealing with developing new varieties to cope better with climate change. The key challenges for our clients usually are they need to produce the right quality and quantity and the right variety. What volume or tonnage of potatoes will come available for sale and when it will come available? And what can I export to where? And specifically also to reduce the claims they're getting sometimes anywhere around the world. Next, please. So a typical example of a service we are providing to our seed customers is we are following the development of the crop during the growing season. So what we need is crop conditions. So we're collecting data, we're modeling activities, and the outcome of it is usually early in the season, is to get information about the vitality as well as on the tonnage of the seed potatoes. And our clients are using that in their day-to-day operations, and as what I said, also in reducing claims. What are we using from the CLMS data is we're using the digital crop conditions. However, we are adding specific information on top of that to improve the products. So we are calibrating the specific potato-specific vegetation index with own reference data. We detect what is called weather-induced growing anomalies, and we support the subsequent derivation of specific phenological parameters during the potato growth cycle. So we're adding extra information to that. On the right-hand side of this, you see on top, it is the yield. So we are producing the yield information during the growing season. On the right-hand bottom is you're getting information in different colors, what lots are available for early export. The greener it is, the better it is well suited for early export. Next, please. There's also a second part in this market, which is called the processing market. So these are the companies involved in providing value-added products like fries, etc. These companies are mainly based in Western Europe as well as in North America. The market value, the turnover is approximately the same for these organizations. And for these companies, the biggest issue there, one of the key challenges is, do I get continuously sufficient potatoes in my factory? Because in case you get a downtime in your factory, it costs them a lot of money. So they lose a lot of money. So for them, it is important to know exactly how many potatoes are coming into their factory and what is the quality of these potatoes. Next, please. And what we're doing there is we are following the crop again during the growing season, the crop condition. We're carrying out all kinds of activities, reference activities, but also modeling activities and collecting the data, doing the quality control. And the The data which we're using is the digital crop conditions. And again, we are calibrating the vegetation index data from the CLMS, and we detect again weather-induced growing anomalies. And based on that, we are providing the services which I'm going to show you now. Can I get the next slide, please? So what I'm showing here is on the left-hand side, it is an overview of from a satellite for all the different lots, all the different parcels. There are all kinds of vegetation. It's not just the potatoes, but these are also other type of parcels like sugar beets or whatever. And what we're doing there, we're selecting the right lots, and based on that, we are carrying out modeling activities and improve those modeling activities with using, in this case, the LAI, so the leaf area index data. And if you look to the green curve on the right-hand side, you will see that that's the leaf area index. And the leaf area index is starting just before planting. And you see that at the moment, the emerge of the plant, of the potato plant is starting. Suddenly the LAI is increasing. On the right-hand side, you see at the end of the growing season, the LAI suddenly drops. So the green curve suddenly drops. This is the moment where farmers are starting what is called haul killing. So they kill the plant to be sure that they can harvest it at a later stage. The red orange is the development of the growing plants and the tonnage of potatoes. And the dots over there are examples of ground truthing, where we are controlling the models we are using. On the bottom, there's also information on the soil available. Next, please. The third segment, which is an important segment, is the enforcement. As what I said in earlier, is that the companies are investing a lot of money in trying to develop new varieties. Just to give you an indication, development of a new variety takes usually 15 years. The investments for an individual company is more than 2 million. So what is being implemented in the sector is what is called the breeder's right, which is an intellectual property right. So the farmers who are using the potatoes, they need to pay a certain royalty for all the potatoes they are using from a specific variety. So what is happening in this, because farmers don't want to pay much data, sometimes fraud, sometimes misuse of this breeder's right. And what we are trying to do is we're trying to detect those issues for our clients. Next slide, please. So what we're doing is, the goal for us is to identify a certain potato variety, an acreage and tonnage. And we are doing that by collecting, again, all kind of satellite data, doing all the classifications, combining it with ground truth data wherever needed. The type of CLMS product we're using is the digital crop type. And what we're doing is we're using currently all available CLMS high resolution layers in our company. And we're also involved in using the in situ point reference data from the Lucas survey, specifically for the product validation. Next slide, please. And a typical example is, apart from providing reports to our clients, we also have an online dashboard where clients and experts can, for Western Europe, review what data we have available for their specific regions. And this is an example where we have identified at the moment about 5 different varieties, but we need to do much more to give you an indication. At the moment, there are more than 500 different varieties of potatoes. So it means we still need to do a lot of work. Next slide, please. So my conclusions: the potato industry is a substantial and also growing sector that is very receptive to make use of satellite CLMS-enabled services. And we have started the first project together with some of these big multinationals. The CLMS is, for us, it's a key data source to support our business. Increasing interest from the large players in using satellite-enabled services for the monitoring, the supply chain logistics, and claim reduction. And we see interesting opportunities to scale up the use of the CLMS data in the commercial sectors like the potato market. Next, please. Yeah, we really would like to roll out our services further into the market, and for this, yeah, there are a lot of things technically. So we would like to get more data and also more higher resolution vegetated land cover component, which is, I think, known as VLCC. Also the CLC plus and the backbone raster products. But also we noticed that for the commercial sector, it is very important to develop an operation environment to integrate our infrastructure with the ones of the core services like the CLMS. We also noticed that it's getting time for standardization of our service chain with a lot of other ground truthing and reference data. And development of more high spectral resolution imaging spectrometers on board of satellites is really needed to identify more than 5 different species, which we are able to identify now. We need to get more partners to develop better potato growing models. The models are fine, but they really need to be improved. And we also need to focus at some of the new data simulation methods to integrate the CLMS data into the fertility and the growth models. Next, please. I'd like to thank you very much, but also make an acknowledgement to one of our partners, GeoVille, who has really helped us in getting access to the CLMS data, but also to help us in understanding what data is available. Thank you.
Thank you very much, Han. It was very interesting. I think this complements a little bit what was presented at the very first presentation about vineyards and grapes. So we see another application of satellite data for growing different crops, potatoes or vineyards or grapes, whatever. So I think it is quite an interesting. I look at the timing. I think we are already at the end of the session. I don't think that there are any specific questions that I can ask. There were few, I think, for Claudia, which were quite generic. Unfortunately, I think she had to leave at 3 o'clock, so she left. I would suggest that we stop here. I would like to thank you very much for the participation. And if there are questions that are coming later or those that were already asked, we will try to answer them offline, so they will be available. Now, just before we stop for 15 minutes now, just before stopping, there were questions about the availability of the presentations and if the workshop will be recorded. So yes, the presentations will be available and the workshop will be recorded. So you can find the information on the event page, usually where you found the link probably to register. So everything will be online after, probably not immediately after the workshop, but a few days after. Thank you. So we'll be back at 3:15, in fact, in 12 minutes, and we continue with the rest of the agenda for today. Thank you.
colleagues, good afternoon. Can you hear me? Can you see me? Cool.
Hi, Marcus. It's Richenda here. I gather you've been in touch with John first this morning, so nice to see you.
Okay, good morning. And finally, I just found the web link. I just sent an alarm email to Eric Anderson. Oh, oops, I don't find the link to connect. I found it.
Okay.
Marcus,
Okay, we'll be back. We'll be back online probably in 15 seconds. Let's say just the time that everybody sits comfortably.
Yeah.
Okay, good afternoon again. Just to be sure that is everything okay? Can we start from technical point of view?
can I just check this is working?
Yes.
Yep, great, thanks.
Okay, so I have the green light here from the technical team. So welcome back. So we are back to the workshop Copernicus for Green Deal. And we had the first session, which was on biodiversity and farm to fork. Now we are back and we'll proceed with the next session in the agenda, which is sustainable finance and sustainable industry. I have to admit this session this topic is something that goes a little bit outside of the comfort zone of Copernicus, and we are used to talk about climate, about land, about biodiversity when we talk about Copernicus, and probably rarely about finance and industry. But we have four speakers. We have invited four speakers that will prove that, in fact, this is not true, and there is really an important aspect of Copernicus data use in this session. So the four invited speakers are Richenda Connell from Willis Towers Watson. We have Markus Repnik from WMO. We have Blas Kurnik from the European Environment Agency and Steve Denton from WSP. So I will ask probably the speakers, when they don't speak, just switch off your camera so we can probably save a little bit of bandwidth and probably also some energy. So I will start first with Richenda Connell. She is the Senior Director in the Willis Towers Watson Climate and Resilience Hub. So Richenda, I'll be happy to hear, and all the participants will be happy to hear from you. So please.
Thank you, Ivan. And thank you very much for the invitation to speak today. Just to briefly introduce myself, as Ivan has said, I'm a Senior Director at WTW, which was formerly known as Willis Towers Watson. WTW is a leading global advisory, broking and solutions company which provides data-driven solutions to clients in the areas of people, capital and risk, and it has a workforce around about 45,000 people across 140 countries. So a very large organization overall. If I could take the next slide, please. I sit within a much smaller unit within WTW, a small but perfectly formed unit called the Climate and Resilience Hub. And we're a team of around about 80 specialists focused exclusively on all aspects of climate and resilience, working with corporates, financial institutions and public sector organizations. And broadly speaking, we're providing those clients with analytics, advisory support and transactions such as parametric insurance products. We also play a very active role, as this slide shows over on the right-hand side, in shaping and supporting international initiatives in climate and resilience, such as the Coalition for Climate Resilient Investment and the Insurance Development Forum. And we also WTW also contributed to the development of the Systematic Observations Financing Facility, or SOF, developed by WMO, and I'm happy to see that Markus Repnik, who's Director of SOF, will talk after me. So very nice, Markus, to be sharing a platform with you today. I'll take the next slide, please. So in about the next sort of 8 minutes or so, I wanted to set out, I suppose, the beginnings of a narrative for the application of Earth observation data, of Copernicus data, specifically by investors linked to the EU Green Deal. And obviously in sort of 8 minutes, I can't hope to cover this topic in a lot of detail. So I'm going to focus initially on a new instrument, the EU taxonomy. And so this slide sets out a quote from Mairead McGuinness, the Commissioner for Financial Services, from a press notice around about a year ago. And this is where we make the link to the Green Deal. So she said very clearly, the financial system plays a crucial role in the delivery of the EU Green Deal. And this is because the financial system directs money towards things that may be supporting a low carbon or a zero carbon future, or they may not. They may also be investing in assets that are vulnerable to physical climate hazards, or they may not. So the role of the finance system is increasingly recognized as being pivotal to making progress in all things climate. And on this slide on the right hand side, I've just sort of put a little circle around this package of measures that were announced in April 2021, and the circle sits around one of the items in that package, which is the EU Taxonomy Climate Delegated Act. So what I'm hoping to do in the next few minutes is sort of tell a little story that starts off with these sort of statements and these high level acts, and then tracks that through to what that means in terms of the application of Earth observation data by investors. I would say that all of this is sort of nascent, growing. There are some investors who are very aware of the potential for Earth observation data, the Copernicus data, to start to solve all things climate, if you like. But for the most part, I would say the investment community is yet to wake up to the enormous potential that Earth observation data has to support them in making decisions that tie into the EU Green Deal. So I'll take the next slide, please. So a little bit of sort of just a brief introduction. You know, what is the EU Taxonomy Climate Delegated Act, and what is the taxonomy itself? And so essentially, the Act is really aiming to highlight to investors what kinds of economic activities, what kinds of investments contribute to meeting the EU's environmental objectives. So at a really simple level, the taxonomy provides a kind of a list of investment sectors linked to NACE codes, which it says can contribute towards climate change mitigation, adaptation, and other environmental objectives. And so the idea is that that helps investors then to sort of, when they're considering making investments, to look through this taxonomy and see if they can invest in sectors, or already investing in sectors that can be seen as contributing towards the environmental objectives. And where we are at the moment with the release of this sort of taxonomy is that they've released lists of economic activities for climate change mitigation and adaptation. Now, they also recognize, the Act also recognizes that not just any investment in any of these economic sectors is actually going to contribute to mitigation and adaptation. It depends how they're designed, it depends how they've been thought through. So the Act includes this important thing, which is this set of technical screening criteria. So in order for an investor to say, oh, I'm getting a tick in a box that I'm contributing towards climate change mitigation or adaptation, there are various technical screening activities that they have to go through to prove that, if you like. So if I can take the next slide, and that talks about those technical screening criteria. And there is a thread here, if you'll stay with me, that is going to take us pretty soon to the Earth observation data. So these technical screening criteria, which are provided in this taxonomy, in the Climate Delegated Act, they are used to define whether an activity contributes substantially to climate change mitigation or adaptation. And what I've done for today is I've focused on the criteria to define if an activity contributes to adaptation. And so the text on this slide is setting out those criteria. And so the first thing is essentially that the activity includes adaptation measures that help to manage physical climate risks that are important to that activity. So that's very obviously, and for instance, a development in a large piece of infrastructure in a flood-prone location would need to make sure that it had got good flood risk management measures in place, for instance. So that's the sort of headline message. And then that gets expanded into a set of technical screening criteria that take us very quickly to Copernicus data, because it says then that the risks that are material to that activity have been identified by doing a climate risk and vulnerability assessment. And it goes on to prescribe in quite a lot of detail how a climate risk and vulnerability assessment should be undertaken. And it talks about using forward-looking projections from the IPCC. And it also talks about using state-of-the-art science, and it explicitly refers, as you can see on this slide, to using open source. It refers to models, but the open source and then the asterisk beneath refers to Copernicus services. So we have this link that starts with saying investors are being encouraged to invest in things that contribute to mitigation and adaptation. And very quickly then this set of instructions is saying, and one way that you need to appraise these investments is by using Earth observation data. I'll take the next slide, please. So then I've got a few slides now where I'm sort of expanding that out and picking a couple of examples of where Earth observation data have been used in this area. So first thing to say fairly obviously is that the Copernicus data helps with the hazard element of the physical climate risk equation. So we have hazard, exposure and vulnerability that together create physical climate risk, and so Copernicus helps us with the hazard element. And so I'm now going to take you through a few examples of projects which colleagues of mine have been involved in applying Earth observation data. So I'll take the next slide, please. Thank you. So this first slide is where Earth observation data were used in Tajikistan to identify where there were climate vulnerability and risk hotspots. And it involved overlaying and developing hazard indices for landslides and soil erosion, which are real key issues in Tajikistan. It's a very mountainous country, and indices for flood, vegetation health, and vegetation vulnerability to increasing temperatures. And these indices and indicators were overlaid in order to generate maps that showed where there were real hotspots of vulnerability and risk, which could then be the target for interventions in adaptation investments to help to resolve some of those problems. So this was targeted investments around more sustainable land management practices. And ultimately, actually, this work fed into an application to the Green Climate Fund by Tajikistan to get investments in some of those measures. I'll take the next slide, please. So this is some work in Monrovia, where Earth observation data together with climate projections have been used to look at built assets at risk and asset value at risk. Now, this example is in Monrovia, which isn't a sort of a particular hotspot for investor real estate investments, but these types of assessments of coastal flood risk, fluvial flood risk, coastal erosion, using Earth observation data are obviously of massive interest to investors who very often will have a large portfolio of real assets, of real estate and infrastructure. Next slide, please. And this is my final slide. So another very clearly very powerful application of Earth observation data is around monitoring and measuring and verifying and having sort of third-party validation of things that are going on. And so I've got quotes here from a couple of really large investors. One is Naveen and the other is BlackRock. And I'm going to guess that most people have heard of BlackRock. So these are massive asset management firms. And Naveen over on the left, so these are two really leading firms who I've been able to get these quotes from. These are quotes from websites that show that they are beginning to use Earth observation data. And so in Naveen's case, they say that when they're investing in real assets, their due diligence and their monitoring processes are making use of spectral imagery and satellite imaging. And they go on to talk about how they're using those, which I'll let you read there. And over on the right-hand side, an interesting quote from BlackRock, who are saying that in the past, they had to rely, when they were trying to assess the ESG performance of a company, they had to rely on self-reported information from those companies saying what they were doing to manage ESG risks. But now BlackRock are starting to use machine learning together with Earth observation data to be able to sort of look at those companies themselves from the sky and figure out if they think that the ESG performance of the companies is really as they have been told. So that's Ivan. I'll hand back to you. Hopefully, just given sort of a taster of what is an enormous potential, very nascent market, I would say, but hopefully just gets us started. So thank you so much.
Thank you, Rich. And in fact, I think this opens the door just to show probably a little bit one of our eyes and look inside, and then probably get more interest. And I think we all know how Copernicus data can be used for risk assessment, identification of vulnerabilities, but we are less aware of how this data can be used for investment, for example. What is the link between? So I think here, you gave us the wish to look probably a little bit more into details, and I'm sure that this will come more and more in the future. So I will invite now Markus Repnik from the World Meteorological Organization, probably to deepen a little bit these aspects and to talk a bit more about financing. Please, Markus, the floor is yours.
Thank you very much, Ivan. And thank you very much, Ivan, for having branded the theme for this session, namely going outside our comfort zone. And with the creation of the Systematic Observations Financing Facility, we are definitely going outside our comfort zone. So this session is about sustainable finance and industry. This session is about weather and climate data and model output products informing investment decisions. Actually, more than informing investment decisions, creating the foundation for investment decisions, as Regenda just stated. This session is also about generating this data in a sustainable manner. Now, here comes in the SOF through a different way of sustainability. I come back to this. It's about closing the major data gaps in developing countries for effective adaptation decisions everywhere on this globe. My name is Markus Repnik. I am the director of the newly established SOF Secretariat, administratively hosted by the World Meteorological Organization. And I want to structure my brief intervention on 3 topics. The problem. What is the problem? And actually, why is it a problem? Second, how are we planning to fix this problem? What is the value proposition of the SOF? Where do we stand? And what are the 22 milestones? And I want to close on why is actually SOF important, not only for Copernicus, but also through Copernicus for the Green Deal. Can you please move to the next slide? So what is the problem? The problem is that you hardly see green on this map. The problem is that we're missing foundational weather and climate observations, surface-based observations, mainly from the developing country world. We're missing this data despite massive inflow of development and climate finance, including by the European Commission. And it's not only a problem, the problem is getting bigger. If you look at Africa, there was a 50% decline of radio sound data internationally exchanged between 2015 and 2020, ahead of the COVID crisis. Now, while we see a decline of availability of foundational surface-based weather and climate observations internationally exchanged by developing countries, our modeling capacity has enormously increased over the same period of time. So the problem is we're missing absolutely foundational weather and climate data from developing countries. Next slide, please. So why is this a problem? It's a problem because our services at the end of this value chain can only be as good as the data on which they're built upon. An immediate step, our model outputs can only be as good as the data with which they're fed. So the problem is, if we have a weak chain, or the weakest element of the chain creates the weakness of the overarching chain. And we have a very weak chain at the beginning related to generation and international exchange of surface-based weather and climate observations. Next slide. So you can ask, why do we have this problem? Why do, in particular, least developed countries and small island development states not generate and internationally exchange this data on which we're all dependent on? Because for each weather forecast beyond the 3 to 4 day, we need, of course, data from across the globe. It is because we have the wrong financing model. We have an unsustainable financing model. We're pumping money into the least developed countries and SIDS. We are providing through resources from development and climate finance, largely investments in hardware, sometimes capacity, but with the expectation that even the poorest country, that even the Guinea-Bissau of this world, are responsible to cover all costs for the generation and international exchange of data, including the elephant in the room, the operating and maintenance costs. This is a dream. So we will not be in a position to increase the amount of data internationally exchanged unless we fix the financing problem, unless we have a new way of financing observations. Next slide, please. So why is there now a lack of observations, in particular of Sentinel disease? Because, as I mentioned, we are missing a realistic and sustainable financing model. We're also missing a sustainable and long-term approach, a systematic approach to strengthen countries' capacity for the generation and exchange of data. In many countries, we have a piecemeal approach of different development and climate finance projects, partially overlapping, partially completing. And we don't have a global design for this. We don't have a global design, and we don't have a globally coordinated approach that matches the global nature of the problem. Finally, we don't have a clearly defined appropriate measure of success. Is the success an installation of a hardware, of an observation equipment, or what is the success? And finally, we're lacking a coordinated and integrated approach towards implementation. Next slide, please. So that's the reason why we have created with many partners, and I will explicitly say thank you not only to Willis Towers Watson and the European Union colleagues, the colleagues from the Copernicus unit, but to colleagues from more than 100 organizations worldwide. This is why we, WMO, together with UNEP and UNDP, have created the Systematic Observations Financing Facility. We have launched it at COP26 in Glasgow. It's established as United Nations Multi-Partner Trust Fund. And it will provide sustainable financial and technical assistance, in particular to small island development states and least developed countries, for long-term generation and international exchange of basic service-based observations as defined and internationally agreed in October last year by 193 countries and territories, namely the Global Basic Observing Network. Next slide, please. So what is the value proposition? We know the problems. So how are we trying to fix these problems? A, through a global approach with a single measure of success. It's not the hardware installed, but the long-term sustainable data exchange as a measure of success with a very clear and internationally agreed metrics, the Global Basic Observing Network. It's about innovating finance. It's moving away from short-term project finance to long-term open-ended finance with results-based elements to this. It also moves away from loan financing, even it's soft loan, to grant financing. Why should the poorest country indebt itself for the generation of a global public good called basic weather and climate data? So it's long-term finance, it's grant finance, it's open-ended finance. It does not end with a project, and it's results-based. Those countries that are going to deliver an exchange, international exchange of data, will get on an annual basis a cashback to sustain operation and maintenance costs of the basic national observation system. So it's about innovating finance, but it's also innovating technical assistance, moving away from international consultants flying in and out to establishing long-term relationships between peers, meteorological officers that know how to operate an observing system, and doing this on a cost recovery approach. Actually, 26 countries have offered their meteorological officers to serve as so-called soft peer advisors, so that the resources and knowledge and expertise of these countries can benefit the beneficiary countries. Next slide, please. So where do we stand? We have launched the SOF, as I mentioned, in Glasgow. We have kicked off the startup phase, including creation of the secretariat. We have actually set up, from a WMO perspective, a technical team to now specify in very detail how to comply for countries with the Global Basic Observing Network. We are preparing and fine-tuning the governance and operational arrangements. We continue stakeholder consultations with CSO and the private sector, and we are in a continued fundraising mode. Just last week, Nordic Development Fund pledged 10 million, Austria pledged 4 million, but definitely we need more. We need $200 million for the first 3 years in order to get going with the SOF. Next slide, please. So what are the milestones looking ahead? A very important milestone, 30th of June, first steering committee, SOF opening doors for business. And by December this year, we want to have funding allocations for up to 20 countries already. And COP, very important for us, we want to bring in SOF from a substock conclusion in Glasgow to a COP decision. And we are going to have, again, a high-level event at COP. Last slide. So why is now SOF important for Copernicus and the Green Deal? First, I think it's obvious for all of you. Global modeling underpins all weather and climate services, including the Copernicus Climate Change Service and the Copernicus Atmospheric Monitoring Service. Now, service-based observations are essential as model input and for modeling verification. And finally, G1 and SOF are designed to substantially increase service-based observations for numerical weather prediction and climate re-analysis. Our objective is to increase the available data from LDCs, least developed countries, and SIDS, small island development states, by a factor of up to 28, and by using not more money than currently invested, by shifting the approach towards sustainable finance and sustainable provision of technical assistance. Thank you very much for giving me the opportunity, Ivan and colleagues, to share briefly what the SOF is about and where we stand. Thank you.
Thank you, Marcus. It's a pleasure also for us to having you here and to see all these different applications, and in particular the last slide where we see how Copernicus can contribute to this. I think it's very important for us. I remember that you said at the very beginning that there is a problem with the missing data. I hope that soon this problem will be not exist anymore, and the data will be there. So the you have to concentrate on the rest of the of your activities. Now, I will move now to Blaž Kurnik from the European Environment Agency, who will talk a little bit on climate adaptation. So Blaž is the head of climate change impacts and adaptation group in the European Environment Agency. So Blaž, it's up to you.
Thank you, Ivan. I hope you can hear me well. Yes, good.
Yep.
Thanks for the invite. Yeah, I will also relate to the previous talks about how to use Copernicus for climate change adaptation, how it's basically linked this to the sustainable finance and also to the taxonomy, which was presented at the beginning of this session. Next slide, please. Yes, so why we are actually adapting, why we need to adapt to the climate change. So it's important to say that adaptation will be important and vital to for the next decades to come, despite successful mitigation efforts being developed. And we can see that, and this is the global, let's say, graph based also on the Copernicus data, that global temperature has increased since pre-industrial period for around 1 to 1.2 degrees. And the last decades, the increase was accelerating. And last 50 years were the warmest in the whole history of the last 2000 years, looking into similar 50 years periods. Next slide, please. When we look in Europe, and my presentation will be focusing on Europe, it's about Europe is getting even warmer. And when we are looking at trends, we can see that basically the warming is above 0.4 degrees per decade in some parts of the Europe. And when we are looking the future, based on the various scenarios, we can see that Europe will warm even further. And we are looking into, in some cases, even above 6 degrees compared to the current situation. So basically, adaptation independently from the scenario, even if you look low or high emission scenario, adaptation will be crucial, and we will have to invest more into the adaptation actions. Next slide, please. And why? And that's basically, it's an overview of the key climate impacts in Europe. And I don't want to go here in any details, but you can see that all regions in Europe will be affected. Some of them with the droughts, let's say increased drought frequency or the magnitude, especially in the center and southern Europe. In the north or western Europe, increased in the storms, and also then we can also count on the spillover effects from outside Europe, effects on the agriculture, and in particular in crop yields due to the increase, let's say, droughts and also some diseases. So all the regions in Europe will need to invest into the adaptation actions to decrease the impacts of this, let's say, climate change. Next slide, please. And this leads me to the economy, to the costs. This is the slide showing the economic losses by climate extremes in Europe in the last 40 years or so. And I must say that in Europe, we are collecting this data from various sources because we don't have a public source of, let's say, harmonized data sets on economic losses from weather and climate extremes. And this is one example which we are holding at the agency. It's coming from the company called CatDat. We have also Munich data. And you can see that basically there is quite a variety in economic losses. In some cases, actually goes quite high, about 40 billions per year. 2021 with the flooding is not included in this case, will be included in the next update. But you can see also variability, and some of the variability is associated with the proper investment, sustainable investment into the adaptation. So otherwise the trend in that will be even, let's say, more clear going upwards. Next slide, please. And of course, when we are analyzing this data, we can come with some of the conclusions. And this is basically based on the data sources which we are getting from Unicre, getting from CADAT. So we lost around 510 billion of euros in the last 40 years or so due to the weather and climate extremes in Europe. And what is more important is that only 23% of this was insured. The rest was basically a loss to the society, and variation between countries is even bigger. Like in some of the countries like Bulgaria, only 1% of the losses were insured. There are some other countries which has quite, let's say, a bit higher share, like Denmark, 56. And 3% of the events were responsible for 60% of all the losses. And the highest losses, of course, are in the richest country, like Denmark and Switzerland, where we are basically registering more than 2,000 euros per capita of the losses. And again, that's quite important to have this data and also to use this data for a proper investment. Next slide, please. Countries have started to develop proper adaptation policies. And here is an overview. Nowadays, all the EEA member countries, which is more than EU member states, have proper or some kind of adaptation strategy and plans adopted. Some of the countries have also developed climate risks based on the variety of the data, including Copernicus. And some of the countries are starting to evaluate these policies, and also focusing a lot on the sustainable finance approach, how to basically invest into the adaptation that actually covers also the carbon benefits for the society. But countries need also data, proper data. And this leads me to the next slide. One of the data sources which we are actually, or platform which we are maintaining at the EEA, it's Climate Adapt. Climate Adapt actually holds a variety of different data, including data sets from the Copernicus services, and actually combines this information with other type of information like case studies, information on EU policies, information on sectors, and also using tools like to support the countries and the region to adapt to climate change. So it's a platform which combines variety of the data, including some of the, let's say, data on sustainable finance. Next slide, please. And one concrete example which I would like to show, which is very linked to the Copernicus, we are having very close collaboration with the Copernicus Climate Change Service. And we are developing together with the colleagues in ECMWF, so-called European Climate Data Explorer, which is feeding into Climate Adapt. And it's basically also used for developing of the European changing climate information on hazards, and also will feed in the future into the EU climate risk assessment, which we are also planning to do. And also we are preparing some indicators based on that. Next slide, please. Another example which I would like to show, it's very much linked to the financing, but it's focusing on the European and health topics, climate and health topics, and it's so-called European Climate and Health Observatory, which is basically having information or providing access to the relevant tools and information which can support the climate and health aspects, including how to different investment needs to be, let's say, supporting different investment or decision on different investments. Next slide, please. And I would like to give you like two examples how in this observatory data from Copernicus are used. We have asked the countries how they are addressing in their policies different, let's say, climate hazards, and how this actually this information can in Climate Adapt and observatory can support this let's say adaptation action toward these hazards. And we can see that, for example, heat waves and droughts are on the top of the priority, and countries are actually needing information on this to develop their proper adaptation actions and invest into the adaptation measures. And another one is also coming from Copernicus Atmosphere Monitoring Service is, for example, on UV, which countries also identified one of the topic to be very much related to the health aspects. Next slide, please. And that's my one of the last slides. it's not only on finance. We also need to look into the social vulnerabilities. And that's basically what is important to understand, that it's also changes in the society which are contributing to higher risk of climate change. And this is the case showing how much the population vulnerable to climate change has been actually exposed to heat waves. And of course, we have more elderly persons in Europe, but also more heat waves. And that's, we can see that increases of the, let's say, cases to affect those vulnerable are, it's quite steep. And in the last years, the increases are even, let's say, bigger than in the past. Last slide to conclude. It's important to make right investment in terms of efforts and, of course, money. And that means that we need to have a robust data for implement adaptation action, not only on climate, but we need to also focus on socioeconomic data. And that's basically what we are still missing, let's say, quite detailed data. We need to share knowledge. We need to share practices across the countries, because as you can see, there's quite a variety in countries. Then also integration between the EU level and subnational level, local level is important, that basically the information flow from EU to national and subnational level is assured. We need to invest into the new type of adaptation, transformative approaches, not only changing, let's say, small things. We need to change completely the system, and proper investment needs to take also for that. And importantly, also long-term solution, investing in the long-term solution is important, in particular when we go to the topics of human health or into the natural-based solution. And here I will stop with my presentation. Back to you, Ivan. Thanks.
Thank you, Blaž. Very interesting. I think with your presentation, we somehow conclude a little bit the financial aspects, but I think what was really important in your presentation is not to forget also the social aspects, because we talk about financial, well, about money, but in fact there is a big impact also on the social aspect, although the session is not about this, but I think it's important to mention. Now I will turn to Steve Denton, who is the head of civil bridge and ground engineering in WSP, who will present also the industrial aspects. So Steve, it's up to you.
Thank you, and thank you very much for the invitation to speak today. So as Ivan's mentioned, my name is Steve Denton. I'm from WSP, which is one of the world's largest engineering consultancies working in the infrastructure built environment and earth and environment environments areas. But today I'm really speaking more in terms of my capacity as the chairman of SEN TC250. And I wonder if someone could confirm if the slides are showing, because I'm not getting them on my screen.
There was an issue with the PowerPoint, so maybe you have to go ahead without. Sorry for this.
Oh, okay. Right. Well, then I'll probably keep this reasonably short. So as I was saying, that I'm talking from the perspective of my role in chairing the committee that's responsible for the standards that are responsible for that are used for structural and geotechnical design across Europe. And these standards are used by over 500,000 engineers, and with construction covering sort of 10 to 12% of GDP, and these being the standards used for the design of all construction works. Clearly, the impact of these standards is very significant. And we're currently engaged in a program to develop the second generation of these standards. The first generation of these standards were published between 2002 and 2007. And we're currently working on developing the second generation of these standards. And of course, when the first generation of these standards was developed, climate change wasn't really a consideration. And so what we do within these standards is when you're designing a structure, and you're designing a structure to take account of loads due to wind or thermal effects or snow loads, then we basically create. Fantastic! So we can skip through the first few slides. If we jump to the next slide, and the next one, and the next one. And the same, we're currently within the process of developing the second generation of these standards. And if you go to the next slide, this is a major program, one of the largest standardization programs in European standardization history, certainly by funding level from the European Commission, which we're very grateful for. If you go to the next slide, and that we are working towards having these standards, this new suite of standards, available by 2026. If we go to the next slide, if we can go to the next slide. Obviously, as I was mentioning, for effects due to wind or snow or thermal effects, then those vary by country. So that although we produce a suite of standards that are common across all European countries and also adopted in many other countries around the world, we have the facility within this structure of design standards to have national information that's contained within a national annex, and that contains the values used for wind and snow and thermal effects. And if we go to the next slide, those national annexes for the current generation of Eurocodes include maps that give information on those climatic parameters to use for the purposes of design. But as I mentioned, with the current generation of the Eurocodes, they don't take account of climate change. And because very often when we're designing structures and infrastructure, we're designing for a long life, it makes sense that climate change ought to be taken into account. So if you go to the next slide. So what you have on screen at the moment is a draft of the new standard for wind actions, effects of wind loads on structures. And the highlighted text highlights that basic wind velocity that we use in the design can be set in the national annex. But if we go to the next slide, the important difference is that we are now saying in these new standards when they're released that the effects of climate change shall be taken into account. And shall is a requirement. It's a requirement of the design that we should, in future, will take account of climate change. And the plan is that we do that by using a scaling factor that's applied to the basic wind velocity. Or if we go to the next slide, when we're dealing with temperature, then we apply like a delta rather than the scaling factor. And we've had long discussions with climate science experts about whether this is an oversimplification of the approach, but it's a convenient approach, an approach that's workable for structural engineers. But those scaling factors, as you can also see highlighted, are things that will be set at a national level. So within those national annexes, countries will be able to determine what scaling factors should be applied. And my expectation is that some may take a relatively simplistic approach. Others may want to take a more sophisticated approach where those scaling factors, delta factors, vary by location, potentially also vary by the design life of the asset that you're designing. If we go to the next slide. Of course, deriving those scaling factors isn't straightforward, and it will be a responsibility at a national level. The national standards bodies in each country will need to develop the national annexes, getting input from the experts in that country. If we go to the next slide, there has already been quite a lot of work done looking at climate science and looking at the principles around structural safety, structural reliability, and combining those two bodies of thinking to explore and to validate the approach that we're looking to adopt. If we move to the next slide. But of course, as I mentioned, if we could just move to the last slide, it's the next one. I mean, simply the point that I wanted to say was that of course, when it comes to the development of those national documents that will include those scaling factors, then the Copernicus work, access to the information from Copernicus, I think will be invaluable for many countries when they come to calibrate those national annex provisions and to use them within the development of their national annexes, which will turn be used for the design of buildings and bridges and other structures into the future. So Ivan, that's my presentation. Very short, but I think what it goes to show is that from an industry perspective and from a construction perspective, obviously the impacts of climate is something that we are looking to take into account in our work, and building them into the design standards that are used across Europe is a very powerful way for driving that. And in terms of the specifics, the values to use, the parameters for those scaling factors, clearly that's a place where we will be looking for support from climate scientists, and the Copernicus work in particular, I think, will be immeasurably helpful in developing those parameters.
Thank you, Steve. Yeah, it was short enough. I would say it was a perfect length to just to present what had to be presented. I think it's very important that we see at the end that you take this into account, and I'm happy that we see that Earth observation, and probably in particular Copernicus, can bring to this, because it can provide this harmonization, for example, which is very important for standards. And depending on the regions, depending on different countries, you can really provide the same value everywhere, which probably is missing today. I'm sure that we, as I said from the very beginning, we opened the door for these kind of applications, which are probably a little bit less exploited today on financing and industry. I'm sure that there are a lot of applications, maybe for some we don't know yet, maybe there are also potential for a lot of other applications, which we start now to realize, and we will be happy to support with more data in the future. I would like to thank you and thank all of the participants for this interesting session. As I said from the beginning, it's a little bit of a different nature. We are not really very much used to work with this kind of applications, but it's a very interesting area, and I'm sure in the future we'll hear much more about this. There are a few questions that were asked, but first, I think we don't have enough time. And then I saw also that they are answered online. They were mainly for Markus Repnik, and we try to answer them online. So I wouldn't go with questions now. I would try also to save a little bit of time for the next panel. I will thank again the participants in this session. If the audience has questions, please don't hesitate to ask. We'll try to answer after that, after the session and after even the workshop. We'll publish the answer as much as possible. Now I will move to the next session, which in fact is not a session, but it's more a panel for questions and answers, where we have 4 participants. And with this panel, we try to cover the different aspects of the today's part of the workshop, which were mainly the biodiversity, the farm to fork, and then sustainable financing and sustainable industry. So as I said, we have 4 participants. We have Anne-Marie Bastrup-Birk from the European Environment Agency. We have Cinzia Voceno from the European Investment Bank, Chiara Sulumini from the European Union Space Program Agency, and we have Alan Bellward from the European Commission, the DG the Joint Research Center, the DG Joint Research Center. So we'll try to address the different aspects, and I'll go one by one through the different participants. They can share their respective knowledge in the different areas. I will start probably with Anne-Marie, as she is the first in the agenda, so I will follow the order in the agenda. I will start with her and just give her the floor to present a little bit how she sees how she sees the contribution of Copernicus in the biodiversity mainly and forestry, and I will be happy to hear also how, Anne-Marie, do you think that Earth observation and Copernicus information can help support the objectives of the Green Deal in your respective area, and are there any concrete contributions already today? What is still needed? Thank you.
Thank you for the introduction and thank you for the invitation to contribute to the panel of this afternoon. And I must say it has been a very interesting afternoon, and I guess former speakers have been so comprehensive that I think it's difficult to say something that has not been said already. But what I'm saying may reinforce a bit some of the things that had been said before. I would say many of the approaches are valid, in fact, for different crops or trees and landscape elements and across the ecosystem. And this is also the beauty of remote sensing, that it links the landscape together. That is an aspect we need to highlight. As mentioned also by many of you, the potential of Earth observation and Copernicus is enormous to deliver actionable information to support the Green Deal and other policies in Europe. And before I start to answer properly, I just want to highlight how I think it's amazing to have access to this freely available remote sensing data. It is something that we should never forget, that it gives huge opportunities for users and for researchers and practitioners. And it's a spectacular progress we have regarding spatial and temporal resolution. And this is to deliver the harmonized and timely and wall-to-wall information, which is not only for biodiversity and forestry, but many other aspects. And the Green Deal includes many objectives regarding forests. The EU Forest Strategy, I want to flag it a bit because it has been less mentioned, is one of the flagship strategies of the Green Deal. And it builds on other strategies, mainly the biodiversity strategies, in fact, but involves many of the climate targets too. It includes also some support to socio-economic functions of forest, protection, restoring and enlarging the forest to combat the multiple pressures on the forest caused by climate change, biodiversity loss, and mention that it should ensure multifunctional and resilient forest ecosystem. One thing I want to mention specifically is that one action regards strategic forest monitoring, data collection and reporting by the member states on forests. So this is something which is in the pipeline, and it refers to the use of remote sensing technologies. So we think immediately of Copernicus and Earth observation and remote sensing techniques, geospatial data, and of course also the ground-based monitoring by the member states. And it flags the importance of Copernicus and also the forthcoming EU Observatory on Deforestation and Forest Degradation and the Forest Information System for Europe, which is hosted by the European Environment Agency. So definitely Copernicus has and is expected to continue to have a role in my area of interest, which is forest and biodiversity. And if we look at the concrete contribution, I think forests have been very much in the forefront regarding the use of Earth observation many decades ago with the GMES, for example. And concrete contribution have been mentioned by Martin Herald and many others. Over time, it has mainly been forest cover types, above ground biomass mapping. But forests are also very vulnerable system because of the long lifespan of the trees, and that limits the forest ability to adapt to the ongoing environmental changes rapidly. So there's a lot of climate hazards affecting forests, droughts and forest fires and outbreaks of insect and diseases. And this is expected to rise in the coming year and might really increasingly compromise the functions of the forest. So we need, of course, spatially explicit, timely and robust methodologies to optimize this information flow and develop effective EU forest-related strategies and policies. But we have a bit of a limit nowadays, and as many of the current service and products that we have are produced with a fixed delivery schedule, and this limits the use of enabling timely intervention when an unexpected or sudden forest cover loss is detected. So I think there will be an increasing demand to use near real-time application. This is for also decision-making and managers to really be able to react quickly to these cover changes and degradation and extreme events. So this demand for near real time and frequent delivery of service and products will be increasingly or are increasingly requested. And I think that with the launch of the Copernicus Sentinel satellites, the potential will also be increasing over time now. Yeah, I think I stop here. Thank you.
Thank you, Anne-Marie. I will have another question, but I will first go through all the participants to share a little bit their thoughts, and maybe I'll come back depending on the timing to see to deepen a little bit more. So I will turn now to just checking Cynthia. Cynthia, thank you very much for coming. I'll ask the same question. I mean, we try to cover the different aspects that were already presented today. So you are working in the European Investment Bank, so you are familiar with investment, if I can say so, because you are dealing also with climate change. You saw we had a lot of probably few presentations, but a lot compared to what everything that was presented today. So how do you see, in fact, this? What are your thoughts about investment and climate change? How do you see the role of Copernicus, for example, in all this? Thank you.
Thanks very much, Ivan. Can you hear me okay? Excellent, thank you. Okay, so my name is Cynthia Luceno and I work for the European Investment Bank, which for those of you who don't know is the bank of the European Union. My work focuses on climate change adaptation, and I work with a team of experts to drive forward the EIB strategies, but also operational processes to support investment in adaptation to climate change globally in the EU and outside the EU. I am particularly pleased to be part of this really interesting event today and talk to you about the role of Earth observation data in adaptation investments. And to answer your question straight away, even hoping not to lose the interest of all the participants, is that Copernicus has an absolute key role to play in informing investments that are adapted and resilient to a future, to our future. So we know that the Green Deal aims to achieve a climate neutral European Union by 2050, and this is of course a crucial commitment to ensure a future to our continent and our planet. But in addition to a climate neutral continent, the EU has also committed to a climate resilient continent by 2050, as indicated in the EU Adaptation Strategy. This was launched last year. Now, this means basically ensuring that the EU is able to manage the unavoidable impacts of climate change, but you can't avoid the impacts of climate change if you don't know them, if you cannot, as accurately as possible, anticipate them. Then, if you do know them, if you can understand them, you can take action to reduce those potential impacts, what we call physical climate risk. And one of the most important contributions of the EU Adaptation Strategy, in our view, is really linking inextricably, once and for all, climate data to adaptation to climate change. The strategy talks about adaptation that is smarter. So adaptation must be informed by robust data and risk assessment that is available to all. And just to really read out from the strategy, it talks about from families building homes, businesses in coastal regions, to farmers planning their crops. And we heard some of these examples earlier this afternoon. So in the next few minutes, and very shortly, because it's late in the afternoon, you might be wanting to run to your cup of tea, I would like to focus on why the use of Earth observation data is so important to a bank like the European Investment Bank, but in fact to any financial actor and also the role of Copernicus in promoting the use of climate data in adaptation investment. Now, the EIB is the Bank of the EU, and in 2021, last year, we approved the first dedicated climate adaptation plan. Now, this plan basically tells a story about how the European Investment Bank will increase its ambition in supporting adaptation inside and outside the EU. And the first goal of this plan, number one, is to support adaptation globally, but adaptation that is smarter. And for us, really, this means investment that are informed by robust climate data. So it's about understanding how climate may change in the future, the impact that those changes may have in investment like a water supply system in Paris or a bridge in Florence, or emergency services in Greece, etc., etc. Mainly infrastructure investments, but all sorts of other economic activities that we may finance. This is for us absolutely crucial, but we need to understand, and this is an important point, that this practice is not common yet. I mean, I am absolutely delighted to hear from Steve Denton that there is an ongoing effort to update the Eurocodes to integrate climate data and climate change considerations, because this is not the case. We still build infrastructure as we used to do 20, 30, 40 years ago, mainly, not always, but mainly relying on understanding that doesn't apply any longer about the climate. We rely on historical data. The use of Earth observation data, but even things like hazard maps or geospatial data is not common practice. So that means that for us as a financial institution, it's very difficult to say, well, no, we just want to finance investments that are adapted to a future climate. The best effort has been made to ensure that those investments, whether they are a road or a bridge or a water supply, are going to perform well despite the increase in temperature, in floods, in droughts, in extreme rainfall, in extreme wind, etc., etc. Not a common practice. This affects the performance of our investments. It means that our clients themselves are not ready to ensure that what they are building or what they are designing is fit for a changing climate. There are many reasons why the use of climate data is not common practice even in the EU, but certainly access to data is now what we see, at least in our experience, the key barrier. It's not really about the availability of data. In the EU, we do have plenty of climate data. And what we see as a wonderful opportunity is the fact that Copernicus Climate Services offer the opportunity to access data that is easy to interpret, that can be then applied to many different sectors, as we heard earlier this afternoon. It can really be used to inform decisions, including investment decisions. So when we looked at this problem in the context of developing our adaptation plan, we realized early on that, of course, all we finance must be resilient to future climate, but the problem is, how do we ensure that happens? And for us, the solution indeed was looking at Copernicus Climate Services as the reliable provider of this information. So we signed a partnership with the European Centre for Medium-Range Weather Forecast, in fact, last year at COP26 in Glasgow. And we are at the beginning of this collaboration, but we hope that really working with Copernicus Climate Services will have a real impact on the climate resilience of infrastructure and other investments in the EU. The ultimate objective for us is really to contribute to a future where the use of Earth observation data becomes a common practice to assess risk to cities, businesses, assets, and any critical infrastructure. For us, there is no other way to go, really. We really need to do this if we are to align with the goals of the Paris Agreement and promote sustainable finance in line with the EU taxonomy, as we heard from Chen earlier this afternoon. I would like to make one final point, if I have not convinced yet, on how important is the use of climate data and Earth observation data in investment. We are seeing a data revolution in the EU, a climate data revolution, and this is extremely welcome. And I'm confident that most actors in the EU will be in a position to access this information to then really influence their own investment decisions in the near future. But this is perhaps the case in the EU, but from what we see in our experience of financing all sorts of projects with public and private sector entities across the globe, this is not the case across the world. And we heard from our colleagues Marcus earlier this afternoon that really there are parts of the world where access to climate data and availability of climate data is still a huge barrier to making good investments for the future. Now, if you are to support a resilient society, as we say in the Green Deal and in the EU Adaptation Strategy, then no one gets left behind. Then robust climate data must be available also to the most vulnerable communities across the world. Really, Earth observation data can become an enabler of just resilience. And I think Copernicus Climate Services has a role to play in this big challenge as well. So I thank you very, very much for your time, and I look forward to the rest of our conversation this afternoon.
Thank you, Cinzia. In fact, yeah, I think there is no need to convince us anymore the importance of the climate data. I think we understand this, and I understand that there is data, maybe not everywhere, not for everyone, not probably the best one that we can use today. And I hope that in the future this will change, because we see how the data, let's say the Earth observation, Copernicus data becomes more and more available and more important. I will retain, however, something that I personally find interesting is that it's not only about availability of data, but it looks like that there is also a kind of a change of behavior to use this data. That's at least what I understand also from your intervention. I think although the data might be there, I think people have to start to use this data. And it was presented, for example, in the previous presentations, is that it's like a little bit like the insurance. I mean, we can all insure, but you see that there are some countries that insure more than the others. But now I will turn now to Chiara to look a little bit also about the industrial aspects, because Chiara, you are working in the European Union's Space Program Agency in the market development team, and you have a kind of a overview about the downstream sector, how the data, the Earth observation and Copernicus data is used in the downstream by different industry, by different companies, by different even the SMEs. Can you tell us more about this? What is your experience, and how do you see the use of Copernicus data there?
Yes, thank you, Ivan, for the introduction and for the invitation to this workshop. Would it be possible to share my presentation? I sent it.
Yes, it will be shot very shortly.
Okay, thank you very much. To start responding to your question. Okay, perfect. Thank you. Thank you very much. Next slide, please. Thank you. we recently published at USPA the first EO and GNS market report, combined the market application insights into a single report that provides global coverage of EO and GNSS applications across multiple market segments. What I would like to highlight today are three market segments selected that are relevant to the Green Deal objectives. In particular, the climate services segment, the biodiversity, ecosystems and natural capital segment, and the environmental monitoring segment. In the report, we cover 17 market segments, so I encourage you to download a free copy if you haven't done yet to have a bigger overview of the market. As a general key highlight, I can say that the EO market revenue are set to double over the next decade from 2.8 billion euros to roughly 5.5 billion. Over half of the global EO market revenues are generated by top 5 segments, including the climate services segment. Next slide, please. Now I'm going to give you a deep dive of each of the selected market segment. Here you can see the climate services segment. This is very relevant to the Green Deal objective to achieve climate neutrality by 2050. This segment is expected to grow double its size over the next 10 years, to grow by 50% over the next 10 years, and the revenue from EO data and services sales by application are mostly driven by EO-based climate modeling application, by climate monitoring and climate forecasting applications, and by climate change mitigation and adaptation. The contribution to the development of this market from Copernicus is very important. We can find the support from all the different data coming from all the Sentinel missions, Sentinel 1, 2, 3, 5P, and 6, and also supported heavily by Copernicus services, by Copernicus Atmosphere Service, Copernicus Land Monitoring Service, and Copernicus Climate Change Service. Next slide, please. For what concerns the biodiversity, ecosystems, and natural capital, this market is strictly related to the Green Deal objective of restore ecosystems and biodiversity. Revenue from EO data and services sales by application are projected to grow steady during the next decade. The main application driving the market is related to the terrestrial ecosystems monitoring, followed by snow and ice ecosystems monitoring, and then coastal ecosystems monitoring and water ecosystems monitoring. Also in this market, Copernicus contribution is very important. We see the utilization of Sentinel's data, Sentinel 1 and Sentinel 2 and Sentinel 3 missions contribute to the development of this market, as well Copernicus services, Copernicus Marine Service, Copernicus Land Monitoring Service, and Copernicus Climate Change Service. Next slide, please. Here you can see the environmental monitoring segment. This segment is related to the action related to protecting our environment in the framework of the Green Deal objectives. the revenues from EU data and services sales by application are projected to grow steadily over the next decade. The main applications driving this market are environmental resources management, impact studies, and ESG, environmental auditing. Also in this market, the contribution of Copernicus is really important. There are data from all the spanning across all the Copernicus Sentinel missions from Sentinel-1, 2, 3, 5P, and 6, but also it's important the contribution to the development of this market of the Copernicus services, such as Copernicus Atmosphere Service, Copernicus Land Monitoring Service, and Copernicus Marine Service. So that was my last slide, and I would like to say that although the EU market revenues are projected to double over the next decade, the international competition is growing fast. We need more consolidation of these markets. The EU Green Deal should reinforce the relevant policies and regulation. On USPA side, we think that we need to continue fostering innovative space downstream applications and synergies among the different space components. In particular, recently we closed our first Horizon Europe call. We had a topic related to the Green Deal and basically how to develop innovative solutions using GNSS and Copernicus to support the implementation of the Green Deal objectives and its policies. This call was very successful. We received 28 proposals, and now we are in the evaluation phase. So basically, through this, we believe we support the creation of new Made in Europe products and services using Copernicus data and relevant to the Green Deal objectives and its policies.
Thank you, Chiara. Thank you. It gives quite a good overview of the different aspects for different policy areas and the revenues. I think I will also repeat probably what you said, that the market report is available. So if people want to have more details, they can download it and see the details. So that there is much more details there that they can see. I will now turn to Alan Bellworth. He's the head of the Food Security Unit in the Joint Research Center and acting director for Sustainable Resources Directorate. Alan, it's not on purpose that we put you last, but I think we arrange the program, and I think you have the possibility to say also the final words. But we'll be interested to hear a little bit more about how do you see, in fact, the contribution of Copernicus for achieving the objectives of the Green Deal, in particular, probably in the food security and the agriculture, and maybe also linked to sustainable resources, biodiversity, etc. Thank you.
I've actually stuck with you all afternoon. It's been an incredibly rich afternoon, and I've learned an awful lot. I think the sort of messages that I've got from the 4 hours and 58 minutes, is it now, that we've been going, is that we have this huge and expanding legal base. We've got climate law, farm to fork, biodiversity 2030, zero pollution, the common agricultural policy, of course, as you say. But there is tropes that cross all of that. And the key words that came up time and time again during the afternoon were monitoring and reporting and verification, if you like. I mean, this is borrowed from climate language, but it goes across all of those different legal areas, I think. And underpinning all of that seems to be two basic axes that Copernicus is going in, and they're the right ones. I mean, On the one hand, you've got all the mapping, the inventories, the indicator work. We heard about landscape features and land cover change and deforestation change. And it was basically mapping work on multiple geographic scales, everything from a field with potatoes and grapes in it, right up to the global scale. So the mapping and the inventory side of it's alive and well, if you like. But what struck me this time as well, and both Guido and Antonio, when they were talking about their field scale stuff, was also time. And I think one of the things that Copernicus has really introduced very much is the time dimension in the analysis. And it's one that's very much at the heart of what we do with the common agricultural policy. It's don't deify cartography, but use the time dimension as well to look at activities. And we're looking at using Copernicus-based markers of things like plowing or not plowing, mowing or not mowing. And so if you combine all of this, I think you end up with 4 principles for Copernicus at the moment. The first is benchmarking. Where are we today? Where have we come from? And that's very much at the foundation of what we see with European Green Deal policy-making process, benchmarking. Second one is trends. Are we in a declining situation, an improving situation, a stable situation? And both of those are real pillars of work that's been going on for many years and needs to continue as well. But I heard also from Claudia the magic words compliance and assurance. Now that's a real game changer when you look at the policy framework. What you're dealing there with is, are you able to detect that in a specific location at a specific time, the terms of that legal framework, whatever it is, whether it's CAP or climate law or LULUCF, those requirements are being met at that time and in that place. If you think about the ploughing that I mentioned before, plough or not plough, it's a single marker, it's a single process from Copernicus. It can have completely different legal ramifications if it's in an arable field that's going to be used for cereal crops or a piece of permanent grassland. In one case, it would be a failure for compliance. In another case, it would be an absolute confirmation of compliance. So you've got benchmarking, you've got trends, you've got compliance and assurance. And I think the one that is growing in importance is the final one, and I've heard various references to it this afternoon, and that's certification. Are all the requirements being met? And that's really the most important one, I think, at the end of the day right now, is can we build up reliable benchmarks? Can we determine accurate trends? Can we then use those in a compliance and assurance framework? And is that whole system robust enough for us to actually go the full story and end up with certification? Yes, you have met all the requirements for the Common Agricultural Policy, for the land use change and forestry, for biodiversity, for, as we've heard, this is not just about the European Union, it's global, it's not just looking at the EU, it's looking out from the EU. We heard about deforestation and trade, are our trade policies actually accelerating deforestation in other parts of the world or not? So we have all of that there. So I think in conclusion, that would be the key message from me. We've got the data processing environment now, we've got the guaranteed supply of the data, although I've heard very little mention of that. One of the elephants in the room is the Sentinel 1B problem that we've got, which is, it's heartfelt now because we rely on these data for building those compliance and assurance systems, for actually making sure that people do that. But as we can guarantee that continuity and that data processing, I think we're at a point where we can move forward. So I would say, don't stop the benchmarking, don't stop the trends, don't stop the compliance and the assurance, but do give more attention to the certification. Let's look right to the end of the pipe. And I think that's the message I've got from today. Thank you.
Thank you. It's very interesting. In fact, I will stay with you now because you have, in fact, the advantage to be, let's say, inside the policy-making kitchen. So maybe I was thinking when Claudia was talking today that space data and in particular Earth observation data and Copernicus data can be very helpful. And in fact, what we see in our day-to-day work is that in fact the space data and Copernicus data provide a possibility for a harmonized and wider approach on decision making and probably monitoring also to follow what are the achievements, to give the evidence there. So what do you think? Do you think that this harmonization, in fact, is important, and what does this bring to have a better policy in you, let's say better coherent policy? Is this something that is this a good instrument?
Yes, I mean, in a word, yes. I mean, JRCs, they are not really the policy making kitchen, as you put it, but we provide the policy makers with the tools to make the policy in one way. But what you've just said is absolutely right. I think if we're using the same measurements and the same metrics, you know, I talked about the markers, for example. Are you plowing or not plowing? Are you mowing or not mowing? We can use those metrics, those techniques in multiple policies. So you're actually using the same reference points, and that will almost automatically lead to better policy coherence. So and that is absolutely essential. Yes, I mean, the three pillars of the Green Deal, the climate neutrality, the leave no one behind, and decoupling economic growth from resource use, they all come with massive co-benefits of cleaner air, cleaner water, you know, healthier people ultimately as well. But you will only get those co-benefits if all those different policy strands that we put at the beginning, you know, farm to fork, biodiversity 2030, climate law, CAP, if they all talk to each other in a sensible way. So the answer is to your question is an unequivocal yes. And Copernicus is unequivocally, in my mind, a key enabler of policy coherence, because you can use the same measurements, the same metrics to the same standards, the same accuracy, the same transparency.
Okay, thank you. So now what we have to ensure is that we have the data, the data that is needed, because
absolutely, and the continuity. Yeah,
exactly. Well, the continuity, as you mentioned, I mean, it's very often in life like this that whenever you lose something, you realize how important it is.
Yes.
But okay, I will stay now with, in fact, a little bit in the nature, if I can say so. I'll be back to Anne-Marie when she was talking a lot about forestry and application of Copernicus data in forest monitoring. But I wonder if you have some experience, and do you think that this model that you use in the forest monitoring, is this something that can be exported largely to support sustainable management of natural resources in general?
Yes, I think as can you hear me? Because there's a kind of
Yes.
echo. Yes.
Yeah.
I want to repeat. I don't want to repeat everything that Alan was saying, but I definitely, I think, and I also started in my first answering. I think that this harmonized approach and wall-to-wall and timely approach makes it much easier to apply a bit the same tool, the same measurements, and the same across. Now we're talking about terrestrial, the terrestrial part, so across that part. But I also, of course, there's specificities, and I think also I support fully the harmonized approach, which is a bit the top-down to get European answers. But I also think that we still have to remember the importance of we cannot monitor everything, but we maybe need to monitor more than what we are saying. For example, we also need to be able to follow some of the ecological processes. And I think with new technologies and new sensors, we are going in that right direction, but we're still dependent a bit on the local condition and local data to construct different training models and calibration and verification and so on. That has all been mentioned before. But the model on forest, which is currently existing, is like a set of services, high resolution and very high resolution services. And so far it has been very useful as standalone. but even more now when it's connected to other tools and other mapping exercise and auxiliary data. So there's plentiful of options already as it is now. I believe that the future is really using even more the Sentinel-2 to have this near real time. And also with the research which is coming on, and there's huge potential for with the more, for example, the sensors mentioned by Martin on hyperspectral sensors and so on, to be more detailed and understand the functions of the ecosystem, which also is needed to support the green deals and the strategies, because it's also all around the ecological coherence that we need now across Europe as a support to nature and to communities and to the bioeconomy. I hope I was relatively answering your question.
Yeah, no, thank you. In fact, yeah, that's right. I mean, Green Deal is there to help, in fact, biodiversity, as you say, and coherence in nature. There is one other aspect also, is that Green Deal is helping to build greener economy, to manage better the earth resources in a sustainable way. So I will go back to Chiara this time and ask, because you deal with closer to companies, can you share some ideas on how Copernicus and EU space data can help companies to address their green transformation? Because this is something important in the future.
Yes, indeed. I think the trends that we are seeing are very aligned with the previous talks. For example, we have seen in the market related to the environment that there is this trend in the investors that are more and more keen to invest in green portfolios, to make sustainable investments, investing in companies that have a high ESG scores. In particular, the environment criteria consider how a company performs with respect to environment. And this criteria is generated using different data sources, including EU data and Copernicus. So through this data, you can assess basically the environmental footprint of a company in terms of emissions. You can see the impact of the activities of the company in the environment. For example, if it's related to land degradation or biodiversity loss, and so it's totally aligned with the previous talks, and we are seeing exactly this trend on the environmental market. But also another important trend that we are seeing is related to the climate services segment, which is driven by the carbon offset scheme, which is aligned with the Green Deal objectives of reducing greenhouse gases emissions. Basically, companies need to meet the emission targets, and to compensate for their emissions, they make investments in emission reduction projects that are usually renewable projects or directly planting trees projects. Then they obtain a certificate for payment of carbon offset. What is the role of EU data and Copernicus there? Is that EU data and Copernicus imagery play a key role providing information over time on the real status of the plantation of the trees, on the real status of the development of the, for example, renewable project, and support the effective implementation. Also provide evidence on the development of the project. So this is some trends we are seeing. Going back to standards and subsidies, it is it's totally important to work on subsidies, grants, and common standards for sustainability to incentivize companies to become greener, to embrace the green transformation. because they see also, they say, the commercial opportunity there.
Okay, thank you very much. In fact, yeah, Earth observation, Copernicus data will become more and more important, apparently. I will come back again to Cinzia about this, because she was talking about data, climate data in investment, and we were talking about the fact that we need to use it more and more. But I just wonder, when you were talking about this, we need to increase the use of this data. But do you have any concrete ideas how we can increase the practice to use this climate data in investment?
Yes, I do. And it's not one action is acting on multiple levels. So first of all, since we've been talking about policies and regulations, we need regulation that promote the use of climate data. We have seen maybe that direction of travel already with the EU taxonomy, also sustainable finance, and the EU adaptation strategy, but those are not regulations. There is not enforcement of the use of climate data. Now, maybe that's far in the future, but we really need to move towards a situation where this is what we do at the national level. So regulation to really ensure that climate data has its role, particularly in infrastructure, is very important. To really create the demand and have a cascading effect on the development of adaptation solutions, research, development, innovation, etc., etc. On the other side, I would say that it's really important to work with all sorts of public and private sector entities to also raise awareness on the importance of using this robust climate information. And that can be done by many actors, including us, including financial institutions, because we have the opportunity to access such a diverse range of public and private sector organizations, and also demonstrate the value of adapting infrastructure on the basis of the use of robust climate data through our investments. So raising awareness and building the capacity, technical capacity to use this data with a variety of public and private sector entities is also a very important way to move to a situation where it really does become a common practice. And then, of course, working with engineering bodies, as we heard from Steve Denton, I think it was, and the importance of integrating climate consideration in engineering standards. Working with cities to ensure that cities do understand what the climate holds for them in the future, and develop adequate strategies and a plan of investments to deal with this impact. So there are many things that we all have to do to get to a situation where really the use of climate data is common business, is what we do, it's just what we do, of course it's what we do. But it's going to take a little bit of time, but we already are in a much better situation compared to a few years ago. So let's promote Earth observation data in the businesses we do, and work together with Copernicus Climate Services to make this data easily available, accessible, and usable for a variety of actors.
I agree with you. Agree that we have to work on this, and that's what we try to do. Thank you very much for this panel. I see we are a bit over time. I have just one question is coming from the audience, which I think, Chiara, maybe you'll be able to use because it's linked to the link between Copernicus and Galileo. So Emmanuel Mondon is asking what, as Copernicus and Galileo, the two space components of the two components of the space program in Europe are providing a high value data set. How do you make the link between Copernicus, Galileo, and the various common European data spaces initiated by the European Commission? If you can quickly answer, if you think that it requires a little bit more time to answer, we can do it also offline. It's up to you.
Yes, I think, okay, this is something at USPA we are working on it. I would prefer to answer offline.
Okay, no problem. Yeah, that's what I thought because it requires a little bit also a bit of a longer answer. So thank you.
Indeed.
I
Thank
will
you.
try to finalize here, meaning just maybe one very last question, what I will ask you to answer very quickly is that we talk a lot about the potential of Copernicus and its coming evolutions to contribute to the Green Deal objectives today. We'll continue tomorrow, but maybe very quickly in, let's say, 30 seconds, how do you see the future? Are you optimist in this? Maybe we can start with Anne-Marie.
Thank you. I see a bright future. I see that it's going to be more and more used and integrated and widespread. There's a huge opportunities in new sensors and technologies, and also artificial and intelligence, machine learning. So I see a very bright use and future. Yeah, in the future.
Thank you, Cinzia. Maybe.
I am absolutely optimistic, and we are keen to demonstrate the value of using climate data and really promote the use of climate data information in the financial system. So you can certainly rely on our optimism to promote the work of Copernicus.
Thank you, Chiara.
Yes, I see it very bright. I see that Copernicus will become not only a space system but a digital system, and we need to increase the utilization of its data, so across all the different market segments. So also with the data and the forecast from the market report, I've seen that there are very promising markets. For example, the insurance and finance market is expected to grow really fast over the next decade, reaching a size of 1 billion in terms of your revenues. So it's really promising, and I see it bright.
Thank you. Alan, I leave the last word for you.
Well, in the course of a very long career, I've often been accused in the early stages anyway of overselling remote sensing, but I don't think you can do that anymore. I think now it's a question of actually underselling it, if anything. So yeah, it's bright. It's bright. Thank goodness.
Thank you very much. I think with these optimistic statements, I think we can probably finish for the day. For the first day of this workshop. We'll continue tomorrow. I would like to thank you very much for participating in this panel. We are online again tomorrow at 1 o'clock. So we'll continue on the climate and energy, zero pollution and transport aspects of the Green Deal and the contribution of Copernicus. I would like to thank all of the participants today and the audience. So I hope we'll see you tomorrow again. Thank you very much. Thank you.
Thank you very much.
Bye.
Bye-bye.
Bye-bye.
Thank you. Thank you.